We still can't hear you, Jessica. Jess? We're not hearing you, Jessica. We see you're online, but we're not hearing you.
Oh, they can't hear us online either. Somebody said you can't.
They can't. I think they're reading. They can't hear that.
Can we start with something else?
Yeah. Who's the next up? Ryan, did you need to go early? Yes. Right.
All right.
Let's skip to that.
So while we work on the technical issues for getting Jess online, we have Ryan Torn here. So Ryan's going to be one of our physical science presenters, and then we'll try and get Jessica and the others on. Ryan?
All right, thanks, Frank. Thanks to organizers for asking me to talk about this area. Even though I'm a physical scientist, I have an interest in this area because I think it's incumbent on all of us physical scientists to be, thinking about how the science that we're doing is impacting people and how we can communicate it the best way. And so one of that ways I think is through probabilistic products that we can produce from ensembles. And so I was asked to talk about some of the possible products that already are being produced and we could produce. And so that's what I'm focusing on. So if you want to go to the next slide. So just a bit of an overview here is that, over the last 30 years, we've seen a tremendous growth in the availability of ensemble forecast. We've done that to try to deal with the fact that the atmosphere is chaotic, meaning that if any kinds of errors and uncertainties grow over time. The problem is these make massive data sets. They are functions of space, time, and ensemble member. And if you're a forecaster, there's just no way of being able to look at all of that data and be able to scrutinize it in making a forecast. I mean, Curtis was just talking about yesterday, the large grids that are being produced by in the new rapid refresh system. And now we're talking about making many of those. So how do we deal with that data volume in a way that's that can be quickly analyzed and serves the users? So even though we've been producing these systems, which again are also very computationally expensive to produce, most of the time people are just looking at the mean and the standard deviation of it. They're looking at the first 2 moments of the statistics. And I would argue there's a lot more information in the ensemble than just those 2 quantities. One of the things I think that holds back ensemble systems right now is that they are not always reliable, meaning that our ensembles are spread deficient. They do not encompass the truth as frequently as they are supposed to do. And so that doesn't justify the cost of doing it. And so we need to work on ways to make that the case. So if you want to go to the next slide, what I'm trying to do in this talk is I'll outline, there we go, is to describe some experimental TC products that one can produce from ensemble prediction systems. And I'll talk about some ones that already have been done or being produced. One of them is an ensemble-based RI product that came out of some HFIP discussions a few years ago. Probabilistic hazard forecasts, the idea of establishing forecast scenarios using ensemble forecasts. And then I was asked to speak a little bit about how one might use this to modify the forecast cone as well. So I'll have some thoughts about that. Another one is the sensitivity products that I talked about on Monday. I'm not going to touch on it here in the interests of time, but happy to talk about that as well. So if you want to go to the next slide, Jennifer. So this is the first TC ensemble product. This was something that Mark DeMaria and I started probably around 2016-ish, where we were actually taking ensemble output from the HWRF model and the HMOM model and producing probabilistic intensity change guidance. And so this is, I want to give credit to John Moskaitis for coming up with this diagram, this stacked bar chart, which is each color represents the probability of a different intensity change category. This is for Hurricane Harvey in 2017. And so you see this, and then the colors or the dots along the top are what actually happened, the actual intensity change category from that. And you see in this case, HWRF did a really good job of predicting when RI happens. The peak almost overlaps exactly with it. HMON did as well. So this was a really nice product. Mark and I wrote a paper about this. It was published last year where we verified these forecasts. One of the critical pieces, though, is that the models tend to underdo the intensity change. So we had to do a little bit of bias correction to be able to get this good performance. So that's a theme that I think is going to run through this. You want to go to the next slide, Jennifer? Another piece of work that a postdoc that and I did, Kevin Bachman, we did probabilistic verification of hazard guidance. And so we took HWRF, ECMWF, and GEFS forecasts, probabilistic forecasts of wind and rainfall, and verified that against best track data, and also in the case of wind, compared it against the Monte Carlo wind model. This is a case from that. This is a figure from that paper that appeared in WAF last year, showing the probability of winds greater than 34 knots for Hurricane Florence from 2018. So the redder the color, the higher the probability of wind speed. And then the black line is what, given the best track data, wind radii, what would you expect the 34 knot winds to be? So in the case of HWRF, it does a really good job of the highest probabilities going right through the wind swath. And then as you go out toward landfall, it goes to lower probability as you'd expect at long lead times. The GFS is a little bit on the north side, so it's missing. It had some very low probabilities in some places where it is observed. And the ECMWF is pretty good. And so we did some verification there. If you want to go to the next slide, Jennifer. Here is the same thing for probability of rainfall greater than 5 inches. Again, with HWRF in the top row, GEFS in the middle, ECMWF in the bottom. Same as before in terms of what the convention is. And then the black line is where 5 inches of rainfall actually happens over land using a land-based rainfall product. Now, each one of these columns is a different way of computing it. And so the left column is computing it from the raw forecast, what just comes straight out of the model. The middle column is what we call a neighborhood approach. So that's basically it's saying if you get more than 5 inches within a certain radius of each grid point, you count it as a hit so that you're not so beholden to being on the actual point. And then the right column is a bias correction called quantile mapping. So we're trying to deal with the fact that the model may not capture rainfall rates correctly. And so what you're seeing is you're going from left to right, that if particularly in the case of the GFS and the ECMWF model, it doesn't predict high rainfall rates very well. And so the quantile mapping actually boosts up the rainfall. And that takes, again, you need to have a big retrospective of forecast to do that. NOAA already does some of that with some of their rainfall probability products. So it would just have to be extended. And in the bottom right there, this is a reliability diagram of that. And in the paper, we go into, what is the role of these different, the raw forecasts are not very reliable, but you start doing bias correction, neighborhood probabilities, you do quite a bit better job. So this is something that a product that could be produced right now. Next slide, Jennifer. There we go. So this is getting into this. One of the things I've been thinking about for a long time is how can we use the ensemble to derive scenarios? Basically, and so instead of a forecaster having to look at every individual ensemble member, how could you kind of group up some of the ensemble members into small little groups that are more representative of outcomes? And so this is the idea of clustering. And so you create some scenarios, and then from that scenario, then you can build on what the impacts are. So for example, this is from Ian. And so the solid line is the ensemble mean, but the dashed is kind of a cluster track that comes out of doing some of the sensitivity work. And so you could say, okay, what would happen if you have a more eastern track, a sooner recurvature, what would that do to the rainfall? What would that do to the wind field? What would that do to the surge? And you could build it in 3 scenarios rather than having a more probabilistic framework. And so I think that there's some work that could be done in this particular area and from the communication side. Next slide, Jennifer. Oh, it didn't do that. Okay, it was supposed to be a click in here, but the next thing I'll talk about is the cone. And so the cone obviously gets lots and lots of play in the media. There's a lot of misconceptions about what the cone really represents. So one of the things that, without getting into the definition of the cone, one of the things I think that's potentially an issue with the cone is it's static, is that every 3-day forecast cone is the same, despite the fact that in some cases we think we know the track forecast really well. And then there's other cases where that cone should be wider because we have more uncertainty into what the track should be. And so I was throwing up a couple of Ian cases here. Ian's probably a case where the cone should have been wider out at longer lead times than what it should have been. And so if you go to the next slide here, Jennifer, there's a couple ways that I think we could use ensemble forecasts to modify the cone and still keep its definition of what it is right now. I don't know, I'll plead ignorance here. I don't know if this has been worked on. I seem to recall something on doing this, but so one thing that one does not have to go all the way to using the ensemble itself to define the cone. I think you could break the ensemble variability at each lead time into quartiles and say, is the ensemble saying this is a low spread quartile case versus a high spread quartile case? And you could have 4 different values of what the cone is at that particular lead time, depending on the ensemble. So in the case of Ian, maybe you're in the 3rd or the 4th quartile of size, and you'd widen out the cone for that particular case. I think our ensembles are good enough in that respect right now that we could have a little bit more dynamic cone that way. The other one is in this ellipse framework that Tom Hamill and colleagues came up with about 10 years ago, where it's looking at, what is the direction, it's a way of visualizing what is the direction of greatest variability. And our ensemble systems are actually pretty good at picking out what that direction is and having spread in both of those 2 ellipse directions. The figure on the top right there is a spread versus error diagram of error in those 2 ellipse directions. And it's actually very well calibrated in the ECMWF ensemble. And I expect that since with the upgrade of the GEFS that took place in 2020, that's also the case now for the GFS system. So that's another way that we could reconsider how the cone is being created. And if Jennifer, you want to go to the last slide, please. So I'll just add some comments here before I close up and take any questions. I think ensembles provide a great opportunity to create new products that we can tailor to different constituencies. I don't think you make the same product for the physical scientists versus the emergency management versus the general public. And so I think we need to come up with different things for different people. In speaking to different constituency groups, I think we as modelers need to work hand in hand with those stakeholders to identify what are their needs? What are their pain points? What are they really concerned about? And, start a dialogue of what can we do with modeling systems to serve those needs in an iterative process. It's not just the forecasters coming up with something and throwing it over the wall. We need to be working hand in hand at the start with the stakeholders. And the other piece is the ensemble calibration is critical. We have to have ensembles that are reliable and calibrated. We're still working on that. There's lots of work on the physical science realm to do that. But once we do, I think we can make a lot of products. And just to give a shout out to, I think, Zach, I don't know if Zach's still here, but these are products that Zach has been producing in real time from the HWRF and the HAFS ensemble for the last couple of years. These are from IDA last year of intensity traces with uncertainty, and then some probabilistic wind and rainfall forecasts. So we're actually producing these in real time. It's just now, how do we get a customer base to use it, and how can we get feedback to make these products even better? So thanks again, and I'm happy to take any questions.
Wallace.
Yes, sir. Hey, everybody. Wallace Hogsett, Hurricane Center. Thanks, Ryan. Quick question on the under dispersion. I feel like for the last 15 years, I've heard that same, issue, and it's going to take a while to address that from a dynamical core and physics point of view. But what kind of work is being done on the post-processing side to like add dispersion where it's necessary? I feel like, especially with tropical inflation. Yeah. Anyway, I'm not fully up to speed on the state of the science there, but I'd love to hear kind of what's being done. Yeah, it's probably tougher with things like precipitation, like two-dimensional fields, but track and intensity seems like maybe we could do something.
Yeah, I think there's a lot of possibilities. So I'll just run through a few of them. So certainly there's bias correction that can be done. So that's why I was talking about with the quantile mapping. So the model you use an old set of forecasts to kind of train to say, okay, when the models really says there's 3 inches of rain, more than likely it's 5 inches of rain, and you can do some moving around to the PDF that way. You can do as Frank said, you can do inflation. There's other precipitation-based post-processing bias correction methods. I know there was a lot out at Esrel that was done on this for the precipitation forecasting there. I think AI methods also offer a very good way to do post-processing for these, because you maybe don't want to make the same correction all the time. And so, yes, there's a lot of work in post-processing in terms of trying to make these better, while at the same time, we're also trying to make sure we capture all the areas of uncertainty in the forecast.
Any questions online? Okay, Ben Wood is next.
Yeah, thanks, Frank. Ryan, great talk. Appreciate it. When you mentioned about the working hand in hand with stakeholders, something that came to mind, I know that the National Water Center and others are working real hard with the FIM, the flood inundation mapping, to really have an education with that product and with other products. So I just wondering, with the ideas you're tossing around with adjusting or modifying the cone or other ways of looking at things, it's probably going to take some education to go along with that. And I know you talk about products for different channels or different groups, but it's going to be hard to keep the other groups from wanting that information too. And so that's where education on all the products could be handy.
Absolutely. Yeah. With the cone, I'm just recognizing the cone is becoming ingrained. And so my thought process is, I don't think we can change or get rid of the cone, but can we at least do something to make the cone a little more dynamic, to reflect the potential error of that particular storm, rather than something that's an average of 5 years worth of track errors, which is what the cone is right now.
John Potterjoy.
And nice talk, Ryan. So one question I have for you is that, have you explored any ideas from, say, the data science community in terms of how you visualize and quantify uncertainty for multivariate quantities? Say, depth-based metrics or other techniques that allow you to apply, similar order statistics, but for multivariate quantities.
I have not, John. I think that's a really good idea, because like I said, these are very large data sets, a lot of relationships between variables. And especially as we go into more coupled situations, I think we're going to have to really think long and hard about how do we do all that. So thanks for the suggestion.
All right, there's some comments on there, but Yai, you had a question.
Yes, okay. So we missed a big piece. So for the hurricane model, we never have a hurricane model or regional model run in simple and operational. So if Ryan want the changes the cone dynamically, we really need a higher resolution simple system in operational. Then you can draw the like 34 or 50 or 64, those when the probability will be reliable. So from the global and simple, so GEFS predicted the intensity much better than the European center and simple. So most and simple from the European centers, the storm are very weak. So even you draw the cone based on the 34. So maybe smaller than the
Well,
in the operational, right?
So- So I was just going to say, in our paper, we found that even though the ECMWF ensemble may have a low bias in terms of its probabilistic 34 knot winds, it was only very marginally worse than the Monte Carlo wind speed model, which is an operational product. Even the 64 knots, again, worse than the Monte Carlo, but not substantially worse than it. So resolution is not a barrier here for doing wind swaths, I think. Rainfall needs more work because there's still more conditional biases in, but we're not as far off on the global models on the wind field as you might think we are.
Yeah, and the two things that I took away from what you said, Brian, is quantile mapping, which is a great way to deal with extremes when you have a bias, especially due to resolution. The second thing is clustering and scenarios. I think that's a major thing to think about. And particularly with AI approaches like K-clustering or the different approaches that you can have in the machine learning space that kind of John was alluding to, where we could actually develop these scenarios. And I know Gus made a comment about how he's been looking at different ways to project the uncertainty using, what does he call it? The bimodal distributions and thinking like that. And even the particle filter stuff that John's talked about as ways to piece out scenarios. So we're going to move on. Thank you, Ryan. I think there's a lot of nice comments about the presentation.
Jess is going to try.
Okay, so we're going to see if we can get Jessica on.
Can you hear me?
We hear you great now, Jess. Glad to have you. I
Great.
gave you a great intro. I hope you heard that.
I did not. So that's the benefit of having a Mac instead of using the government furnished equipment to try to get on Zoom.
Yeah, well,
But-
I basically said that HFIP is blessed to have great partners on the operational side to help us address these issues with dealing with communicating a risk, and that how the Tropical Service Program is really leading the charge on trying to address our products and services for the hurricane stuff. So with that second intro, go ahead, Jess.
Yeah, thank you, Frank. And I'm really actually glad that Ryan was able to go before me, because I think he spoke to a lot of the things that I'm going to speak to, but in the language that you all probably understand a bit better. So so thank you. I am the NWS Tropical Services Program Manager. So I in that capacity, I'm in charge of policy for the National Weather Service for tropical cyclones. If you can move ahead to the next slide. So the thing that I wanted to get through today actually came to me as I was helping my son with an assignment for school. His school is called a Leader in Me school. So they every month they focus on one of the 7 habits of highly effective people. And it got me thinking, because this month was begin with the end in mind. And the quote there from Stephen Covey is to begin with the end in mind means to start with a clear understanding of your destination. So, and with that, I was thinking, why do we do what we do? I mean, we're essentially, we're trying to find out more information about hurricanes and to get the details correct, improve our forecasts. But ultimately, we want those forecasts to help save people, to help them make good decisions, to help them protect their property. So, that's really what I want people to take away from this is, how is what your part of the modeling community, of the science community, how does that, what's the ultimate goal of what you're doing? So go on to the next slide, please. So essentially, how do we get from like these, ensemble plots that show some uncertainty, that, there's a message in here. How do we turn that into information that can be used to make decisions about whether or not we should open shelters, and provided to people for them to make their personal decisions about, should I go to the shelter or not? So that's just one example. Move on to the next slide. So, and this is really starting to get baked into a lot of the strategic planning documents that are out there. And this is from the Weather, Water, and Climate Strategy that I believe just came out. These are the kind of questions that we all should be asking ourselves about. What we're providing publicly. Like, how are people using? What kind of information do people need? What mitigation actions need to be taken? How long will each one take? What is the expected extent and of duration of the wind, of the coastal flooding? So, just reading those questions kind of made me think about some of the gaps that there are in our current product suites and in the guidance that's provided. So next slide, please. So this is where the tropical roadmap kind of comes into play. The tropical roadmap is an effort to innovate or modernize our tropical products and services. It was kicked off mostly through an effort from the Hurricane Harvey supplemental that funded these 4 primary social science research projects. And you're going to hear more about this when Gina and Castle talk in a few minutes. But that was kind of the impetus for it. There's a lot more social science obviously going into it than just these 4 projects, but there's been a wealth of information over the past, at least the last 10 years that's been focused on tropical cyclones. And we can help, or we can triangulate that information to come up with actionable recommendations to move forward with making our products more understandable, making them more pertinent to our partners, to people who are making decisions. So, and then in addition to that, there was a lot of talk in Ryan's presentation about partner thresholds. What kind of information do our decision makers need? We are cataloging that kind of information in the Weather Service right now as part of the IDSS management system, which is a fairly new project, at least the part for collecting partner thresholds. And what I mean by partner thresholds is, like, say, and I'm going to use this example later, but like if I'm a train operator and I know that if the winds are going to be over 50 miles an hour, then I have to shut down my operations. So I'm particularly interested in that threshold, where somebody with, who operates like a sailing, charter business, they might have a lower threshold than 50 miles an hour. So this IMS effort and the IDSS management system, they are trying to catalog all these different partner thresholds for actions. And then there's also recommendations that we have gotten through assessments of services. That could be through the ICEWG, through NOAA server or Weather Service assessments, et cetera. We want to integrate those recommendations into our future products and services. There are new tools that are coming online, especially on the Weather Service local forecast office side. There's a high dependency on a tool in their software that they use to get the forecast out, which is called AWIPS, and the new tool is called Hazard Services. And we are going to be transitioning all the local office information to this Hazard Services tool in the next 3 to 5 years. So we need to start planning for that now, and it's an opportunity for us to change our messaging and to change the format of these products and to provide things in like GIS formats that we can't or we haven't provided in the past. And then also there's most importantly for this group, the advances in science and modeling. And so that's an important part of how these new products and services are going to look in the future. I mean, every day we're coming up with new ideas. I heard a few just in Ryan's talk, but I know Mark De Maria and Andrea Schumacher are working on the new statistical based wind speed probabilities. And having that inland wind reduction, how that's going to impact our products and services and the messaging of that, because it's going to look very different than what we see now. So all of this is going into the advancement of the products and services that the public and our partners see during a tropical cyclone event. Okay, next slide. So kind of need to balance with how much skill we have with, you know, the information, with what's going to be done with that information, to determine if we, you know, are providing quality enough information on a consistent basis at, like, say, the D6 and 7 range, which is a really important time range as far as, you know, getting, you know, gasoline distributed correctly, because, you know, there's going to be high demand in a place where there's going to be impacts. Moving shelter, you know, cots, etc., you know, to the right places, so that there's, you know, where there's going to be need, that there's, you know, supplies. Same thing with, like, groceries and you know, the logistics. So there's actionable, a lot of actions are going to take more than just that, you know, 3 to 5 day period where we've got watches or a cone out there to make decisions. But we know that the measure of predictability is not always the best at, you know, day 6 and 7. So do we want people making decisions? And I think Ryan was getting at that there are times when we do have more information and more certainty in what may happen. So, but how do we handle those outliers? Like, is it possible for us to use, you know, dynamical models to populate public facing products to help people make these decisions? Next slide, please. Next slide, please. Thank you. Okay, so so we know that there's, you know, an effort to explore expanding out the tropical weather outlook to 7 days. There's also been some work that's been done on extending out the current wind speed probabilities to 7 days. But, you know, how much, and I'm hearing, you know, there's some of this work going on now about incorporating dynamical information into the TC wind speed probabilities. Or into just what wind speed probably, not necessarily like these that we think of as the statistical ones, but ones that come out of HAFS or other ensembles. Next slide, please. So, and of course, this isn't just restricted to wind. I mean, there are, you know, needs for more information, you know, and uncertainty information for things like wind gusts, for flooding, for landfall intensity, and for storm surge. But, you know, the question is, what consistent level of skill is necessary to incorporate dynamic information rather than just statistical information? And so that's one of the things that that this group is clearly working on. Next slide. So taking a look at some of the, you know, how the products and modeling products are used by the Weather Service forecast offices. And you see an example there on the left. This is called the Graphical Hazardous Weather Outlook. And this was during the event, like Eastern Pacific Hurricane K, that was offshore of Southern California, and there weren't any watches and warnings there, but there was a clear, you know, impact of the wind field in that area. And you can see that there's, you know, much of this is driven by topography. This is also like the case like of Puerto Rico and the Pacific Islands. You know, we generally just use, you know, a crude multiplier at the forecast offices to generate a wind gust grid. Is there more, you know, more detailed information and more uncertainty information that can be provided for wind gusts? And, you know, how much can we explore that? And how much more, you know, I'm comparing there on the bottom right, you see what the wind speed probabilities look like for tropical storm force winds during the storm. I mean, clearly this was outside of the inner core of the storm, or where the wind speed probabilities are valid. But, you know, what about those areas that are just outside, especially when we have a gradient wind? Like, we're going to have that situation with Nicole. We've had that situation with Ian, where this boundary between the tropical or subtropical cyclone and like a cold front, you know, getting that information right, where the people are, where it's impactful is really important. Next slide. So, and then how we convey this information is really important too. So will a user understand exceedance products? Like I gave that example. Okay, you're the train operator and you need to decide whether or not you're going to close down operations. And it's $1 billion decision. The current products that we have, are like that we would show them, like from the official product situation standpoint from like NHC, would be like 34, 50, and 64 knot wind speed probabilities. Notice I said knots. I don't know if knots means a lot to somebody who's a train operator. So how can we provide that information to them in languages that they understand? And also, like if we give them something like exceedance products, make it clear that this is essentially like a reasonable worst case scenario with a 10% exceedance, and that you're providing like really a best case scenario. I don't even know if you'd want to provide it with a 90% exceedance, but like, providing that range of solutions is also important, because you lose confidence and you lose trust from people if you're only giving them the worst situation all the time. And it obviously is not going to materialize in most cases because of that. Next slide. So, and this is kind of a look at this through facets. And so you can see on the right, the wheel there for facets. And in this case, we're talking about changing the driving wind speed probabilities, and how that kind of has a ripple effect all the way through to, the point of when and who are going to board up their houses. And what are those products going to look like, and what's the messaging going to be like in the the usable data category? So things that are on hurricane or weather.gov, where a lot of people get their forecast for their zip code. Will it change our targeted observation strategies? How's it going to change our verification? There's ripple effects whenever there's a scientific breakthrough on your end, that go through all the way to that end person who's making the decision about taking action. Next slide. So, and this is another quick example of how like changing something like the wind speed probabilities that really make a difference in things downstream at Weather Service. And this is on the left, the composite, like basically the deterministic forecast in the current wind speed probabilities are used to create a recommendation for the local forecast offices on whether or not to put up inland watches and warnings. And so that all has to be recalibrated if we were to change those wind speed probabilities. Same with on the right, you see this is a screenshot from weather.gov. This is what a lot of people get their forecast for their house. And it says things like tropical storm conditions are expected with hurricane conditions possible. That's all driven by those wind speed probability information. And if we change the wind speed probabilities, then that has to change the calibration for when those expressions come up and how they change on the website. Next page or next slide. So, and then visualizations are really important. Like what is going to help, what's going to be easy for a user to understand? Somebody who's not a scientist. I mean, that's ultimately the goal, is to get people who are not in science to understand what their risk is. And so are there different ways that we can display this information that is more intuitive to them? Next slide. So in summary, there, obviously the need for actionable information to be provided in a fashion that decision makers understand and they can easily use. So, while there's, a lot of work being done on the modeling side, I think that, and there is work being done on coming up with those thresholds that are important to partners. There's like a synthesis that's needed. And that's why that last bullet is really important. That communication between the modeling community, the social science community, and the operational community is key for helping meet these decision makers' needs. So we're asking that you begin with that end in mind, like what think like that person who needs to make the decision about whether to close down the trains. How is the work that you're doing helping with that? And there are critical decisions that are really made at that day 5 to 7 range. And really having forecasts over land that are more, better and can, and be more detailed within the realm of reasonable, the skill of the models is really important for us to focus on. Next slide. Okay, and that's all I had today. So again, my name is Jessica Schauer. I'm the Tropical Services Program Manager, and I thank you for having me here today.
Jess, so we have some questions online, I think.
Okay.
Andrea?
Hi, Jessica. Thank you so much for. I love the framing of begin with the end in mind. The one thing that really strikes me about that, though, in terms of the process of product development introduction, is that the end often is where we need to involve the people and what people need and how they interpret. And that's where the social science is. And it still seems like in a lot of cases, the social science comes in after we have a product to sort of tweak the product. And as we know, just from trying to update these wind speed probs, that's really hard. Once people are used to a product, it's really hard to change it without having some major ripple effects and consequences. So I guess my overall question here is, how do we get social science involved earlier in the development phase? And I think a great example is this idea of the dynamic cone. I mean, I'm pretty sure there's a lot of people on this call who have worked on a dynamic cone from a development standpoint. I've made a dynamic cone. Other people have definitely made a dynamic cone, but the problem is the messaging, because dynamic cones tend to have this risk of not being aligned with the official NHC track and intensity forecasts. Same thing with scenarios. And so the idea here is, we need to understand how people interpret these first before we can go back and actually create these. So do you have any thoughts on that?
Yes, thanks, Andrea, for your question. I think that we're kind of at the infancy also of having social science basically as a program within Weather Service and within OAR. And the spin up period is still occurring. But we're going to hear from Castle today, and I know on the Weather Service side that they're working on looking at all the past work that's been done to try to start triangulating and coming up with overall recommendations for product and service development, so that there could be a set of best practices that are provided even before you get started on even working on the modeling end, so that what the expectation is for something before you get started on visualizations, et cetera, that there's like some guidelines that are there. And I know that a lot of work's been done in the last just few months on this, and it's really just kind of getting started. But between that and having a catalog of things like those impact thresholds, like we talked about, things that are things, certain thresholds for precipitation or for wind, or et cetera, that are really important to people, I think can help focus the modeling and the product development as well.
Yeah, great.
All right.
It's a good first step.
I have a question here from Aaron.
Thanks, Frank. This is more of a comment for Andrea than anything. From the HFIP PM side, that I'm new to the position, but that's one of the things that was immediately noticed is the social behavioral and economic science aspect of what HFIP is tasked with has kind of been on the back to middle burner. And now that HAFS is making that transition to operations, it's one of the things we want to really bring to the forefront from the program side to not only fulfill what we're tasked with, but because of the vast importance of it. So I'm glad that you were bringing that up, and everybody that's doing this is capturing it. And obviously Frank's been super supportive, not only from setting up sessions like this, but just his passion for that beyond the science as well. Thanks.
Yes, and I second that. I mean, really, thank you, Frank, for kind of bringing all of us together. Like I said, we need all three legs of that stool to really be able to meet the end needs and help people make better decisions.
Yeah, one comment I would make is the first 2 days of this meeting, the end in mind that most of the presentations had was getting the track and intensity forecast better compared to the best track. That's not our goal. Our goal is what Jessica's talking about. And, if we keep locking our minds around those three numbers instead of what we're really trying to focus on, which is providing information that can elicit a response, we're missing the point. And so my challenge to the physical scientists and the model developers and the forecasters in the room is, let's elevate our attention to a different goal. And not get buried in this, oh, well, I got 5% improvement, of the track and intensity. How does that translate to the products? Stan had a comment, and then we're going to move on to Gina. We're going to have a big discussion after this. So I'm just throwing smoke, oil on the flames or whatever.
Yeah, just a reminder of something Dr. Neil Frank said many, many years ago. He said we could have perfect forecast. So forget getting better. We get a perfect forecast and the public still doesn't know how to respond. And so, yeah, I agree. This is the one thing I learned from your talk that I don't think of much is how many different users there are and how dramatically different. But the final thing is, boy, that 6 and 7 day, what a black hole, because you get people used to that. And I think, what would a 7-day forecast of Andrew have looked like? I mean, sometimes the storm isn't even there. We're not even thinking of the storm 7 days in advance. So it's a very tricky kind of thing. So thank you.
All right. So I know we have some questions in the room. I'll try and handle them quickly so I can get Gina up there. I mean, we have one less speaker, so we do have a little time.
Just a quick comment to what you just said, Jason Sipple. You know, in ATCF parlance, you know, for verification, one immediate thing that pops out at me that is relevant to your question is suddenly verifying wind radii becomes one heck of a lot more important than necessarily verifying intensity, right? That affects a lot more people.
And I have one more comment from Bill Ramstrom.
Hi, Bill Ramstrom in the modeling group. It was really a good thing to remind me, you know, when you showed the map of Southern California. So, you know, our models definitely generate sustained winds at really high resolution that, you know, we heard Dave Zielinski talking earlier about. That's great. They can look at it on the web, but it's not in their AWEPs where they can produce a product from it. The other is, you know, we're not actually really generating a good wind gust product out of the model. We could. So that was an interesting reminder about, you know, to keep that in mind.
All right. Thank you, everybody. We're going to have a discussion after this, but I want to get Gina up there because we've heard about what she and Castle are going to talk about. Gina Diasco is our social behavioral economic science lead. I don't know if you're a program yet, Gina, but she's an OAR. And she and Castle Williamsburg are going to talk a little bit about some of the projects that have been funded through the supplementals and where we are with those. Go ahead, Gina.
Great. Thank you so much, Frank. And we are indeed a program. We are the social science program in the weather program office in OAR, and we are delighted to be here. As you can see, I'm virtual. We used the forecast information the last 3 days, and we decided to jump ship. And I will tell you that I didn't think how funny it would be to mention that I was afraid of turbulence to a room full of meteorologists and researchers that have been on hurricane hunters before, and that you all, you know, just find turbulence joyful while I sit over here with fear of turbulence. But I will say, I've been monitoring my confidence in my decision by looking at the delays at Miami Airport. In just in the last 10 minutes, they've gone up from about 20% to 40% of their flights are late or very late. So I'm actually feeling very confident in the forecast. And I knew that my decision threshold needed to be Monday because flights would book up. And so I used that as an example of someone who needed to make a different type of decision using the tropical product suite. We often think about evacuations, but I needed to use it for travel decisions the last few days, and knowing that I needed to get back, and I couldn't, as much as I wanted to, I couldn't stay the next few days if I did get stranded in Miami, although it would have been a wonderful place to get stranded. So again, I use that as an example as we consider these products and what they do, or perhaps even what they don't do, maybe what they can't do yet, because we need more physical science. These are the types of fundamental questions we need to be asking about what decisions, what is that end goal? What are the decisions that people are using that can influence the use and value of the research, development, and operations that we're doing today? And so I want to double check, are we sharing our screen, or are you all?
That was my question.
We weren't sure if you all were controlling the slides.
We can do it.
Why
We're
don't
happy
we do
to.
it? Yeah.
Yeah.
Castle, do you mind?
Coming right up.
Gina,
Okay.
which way do you prefer? Because we can do it either way.
If you guys control it, that's great, because then we can see our notes. That's fantastic. All right. Well, we're really excited. Thank you for Jessica, for Ryan. Oh my gosh, I actually got goosebumps this morning already. That it's like a buzzword. It's conference bingo, the synergies, but really, truly, I felt the energy from the earlier presentations and the questions from the audience. Andrea, I felt like you teed us up perfectly. So as you may know, we've been working as a team. While WPO is presenting this presentation, this is very much a team effort. You can see all the names in the slide. So this has been an effort with the Hurricane Center, with the Tropical Program and Weather Service, with the Weather Service Up and Coming Social Science Program, and the Weather Program Office Social Science Program. We have been working as a team since that supplemental became a thing. In 2017, we got buzzed, and then in 18, it became a reality. We have been working on this for over 4 years. Of course, the last couple years is when we've had projects. So next slide, please. So as you may recall from previous HFIPs, these are the 4 main projects that we funded. And I did note and look on our attendee list, we do have some of our PIs online. So Rebecca, shout out to you and thank you so much for all the work that you and the NCAR team and colleagues have been doing. But of course, thank you to all of our PIs on this slide. What we've done is all of these 4 projects have produced final reports. Some of them are up on the NOAA Institutional Repository that are publicly available. We hope to get them all on the Institutional Repository, so they're all publicly available. However, what our team has been doing, the collective team, is taking each individual report, knowing that you all may not have a ton of time, because they're very long and detailed, a ton of time to do that. We've been reading through all of these reports and trying to synthesize what are the cross-cutting findings, because you may recall that the way these projects works, it was a very purposeful complementary design. That is, some projects both looked at uncertainty, but in different products. Some projects both looked at emergency managers, but in different contexts. And so the findings could be sort of combined to produce larger, more confident, and in some cases, more generalizable findings. And to give a little bit of background on that, I'm going to hand it to my sort of co-host of this presentation, Castle Williamsburg, who's actually been leading a lot of the R2O efforts for this project. So Castle, to you.
Thanks. Go ahead and go to the next slide, please. So that purposeful kind of arrangement that Gina just talked about is really what lets us do this thing called triangulation. And so if you're not familiar with this, in the social science kind of arena or area, we use triangulation by kind of incorporating multiple approaches to approach a research question. So you might combine the findings from 2 or more rigorous approaches to really get a more comprehensive picture of what's going on. And so because of the way that these projects were designed, it gave us a really unique opportunity to start doing this. And so this presentation will be kind of skimming the surface of all of the really amazing triangulation efforts that we have going on. And we're excited to show you and reveal some of our kind of research development operational ideas to get your feedback, because that's really what this is about, is this iteration phase. And that's a nice transition to the next slide, if you will, to kind of give you an overview of what our triangulation process really looks like. So when it comes to our triangulation, what we ended up doing was, yeah, next slide, you were right. Yep, perfect. So what we started with was if no one's familiar with Miro, it's essentially like an online whiteboarding software. And so that gave us a really cool opportunity to just kind of put everything on the table and for us as a team to work and kind of find those really important connections to start doing this translation. And so when we talk about triangulation, we really are thinking about it in terms of how are we translating these project findings into transition opportunities, both for like research to research, research to development, but also research to operations as well. And so once we kind of got some of those initial findings and ideas, we iterated with the Tropical Roadmap team, maybe 3, 4, 5, 6 months ago with some of our initial ideas. Then we went back to the drawing board after getting that feedback and continued to iterate. And now we've gotten a bit closer, and we're really excited over the next month or so to iterate again with the Tropical Roadmap team to continue refining these ideas, making sure we're taking into account a lot of the physical science needs as well. Because it's really, what's been really cool and fascinating about this process is seeing how social science is influencing physical science and vice versa. So we're really excited to continue refining a lot of these ideas to make sure they are operationally viable, or we're wording them or moving in a direction that kind of creates some of that opportunity. And so this is really a nice roadmap, our own roadmap, our triangulation roadmap, if you will, of how we're thinking about that process. And so we're currently at the end, but you'll see that there is that circular arrow. So this is a time of iteration where we're making sure we're working with a lot of different stakeholders across NOAA to, again, make sure that what we're putting forward is really operationally viable. So go ahead and next slide. And this one will go back to Gina.
Yeah. So with that, we're going to go over a lot of suggestions today, but I wanted to start with the most positive one, because I know that as a researcher myself, that we can often just look at things and we get really excited about what's the next new thing, what's the improvement. But it's also really important to reflect about the value of what we do as well. And I want you to know that one of the biggest findings of all 4 projects was that people are overwhelmingly find the product suite useful and important. They are so appreciative, and they being public broadcast meteorologists, emergency managers of all different types. We sort of use those words, but they do represent a very diverse group of people. They find what you are doing, both on the research side and operations, useful and important. And so please just take this moment, pat yourself on the back a little bit, take a deep breath, and just know that's literally a finding from these projects before we go into any of the actual changes. So great job, HFIP. You're really making improvements, and our partners are really seeing that. Now, with that said, the rest of this presentation is about all of the synthesized findings on what we've found that we need either improvements, changes, and enhancements. So with that, the rest of this presentation, Castle and I are going to be tag teaming. Castle will go over each of the overarching findings, and I will communicate how we're thinking about translation. So with that, next slide.
Awesome. And so you'll see a bunch of these like kind of story markers, if you will, because we're trying to kind of tell some of these really important high level stories. So really the first one that we want everyone in the room to walk away with is that people use and benefit from probabilistic information when making decisions. This was very clear across several of the projects that we incorporated in the hurricane supplemental. But the next part is what's more important and a bit more in that translation space. If we provide short explanations that describe how to interpret probabilistic information with a graphic or a product, that can significantly improve their understanding. So they already have an understanding of probabilistic information. But if we go a step further to provide a short explanation, we can really start to see how their understanding improves significantly. So go ahead to the next slide. And we saw this really with the numeracy study that was kind of within the hurricane supplementals. And this one was with Joe Rittberger and his team. And what they did was they had 4 different studies that set out to map comprehension across a variety of different stakeholders, emergency managers, weather forecasters, as well as the public. And on the left side, you can see what kind of how the general numeracy fell out for those different user types. And so what's interesting to see and point out is how closely aligned the emergency managers are with the publics in terms of their numeracy. And when we talk about numeracy, it's really essentially someone's literacy with numbers or how well they can use numbers. So we think of emergency managers as some of these super users, but when we kind of see how their numeracy in comparison to both the public and forecasters, they're actually a bit more closer to the members of the public. So that has really important takeaways for the products that we're providing. Another important finding that emerged was that a majority of forecasters and emergency managers used vague words and phrases. So kind of using qualitative descriptors versus these precise numbers to explain probabilistic information. And when we see what that happened was that when they provided some of those really vague words and phrases, it led to members of the public or people that were receiving those messages not using them as effectively because they were not being given that precise numerical information that would allow them to kind of navigate some of the complexities of the probabilistic information. So there is this underlying perception that members of the public and partners may not know how to use probabilistic information. But I think the really important thing that came away from the study was that maybe the way that forecasters are retransmitting or rebroadcasting that probabilistic information in a vague way is likely leading to the lack of use of probabilistic information from a decision point. So this really, again, translates to what we see and how we're trying to think about this in a broader term. So Gina, I'll let you take the next slide.
Yeah, great. So next slide, please. So we have, we know there's an affinity to cats. So we were working really hard to find a new acronym. However, it's purposeful. And actually a lot of the earlier discussion about a dynamic cone, it's gonna make sense with the next slide. We've been thinking about static versus dynamic as well. So in this particular context, this is about communication assist text. So if we know that probabilities enhance decision-making, we know that. And if we know that our forecasters sometimes, and not just weather service, let me be very clear, when I say forecasters, it's the whole public and private community. We know that they're not always translating or communicating that uncertainty. So what we need to do is try to provide some additional ways to communicate uncertainty. We need to encourage that, but we also need to do it with our products and services themselves. So the idea here is that we can provide a static communication assist text, a CAT. Right, so and I should say this is transferable, not just to tropical, but this idea could transfer any hazard, any really environmental area that was communicating uncertainty. And the idea is to just provide a description of the uncertainty, basically give them a sentence that describes the map. And you see the example here, right? And I believe actually with the storm surge flooding map, this is actually sort of an example that already exists. So compliments to the Hurricane Center for already doing this. Now we just need to do it further along all of our products and services that have an uncertain dimension. But what's more, if you go to the next slide, there are also dynamic CATs, right? There are dynamical ways that we could do this. So in other words, we could click on a map, and the map where we click, it could give us that assist text, that CAT, specific to our area. Or conversely, you could put in your address or zip code and that information could come up. Zip code, we actually were thinking while we were making this, well, that could be problematic because there could be multiple surge levels in one zip code, right? But all this to say, there are varieties of ways to use maps in people's locations. And in doing so, it's personalizing the message as well. So if they're putting in their location, we wouldn't save their location, that's PII, right? But we could pinpoint where they are, what category of surge they're in, right? What bin, right? And as you see on the message could be very specific to them. We heard a lot about needing to personalize and localize information, and we've been trying to sort of incorporate that in our translation ideas. Next slide, please.
So this leads us to our second big topic area, which involves timing information. So from several of the projects, we were able to identify that different types of timing information, so for example, onset timing, cessation timing, as well as duration information, are really critical for decision making. But that kind of lines up something else, which is the timing of when products, forecasts, and data are released to partners is also important too. So kind of two different elements or flavors of timing that are really interconnected and important for us to kind of explore further. Next slide. So when we think about the timing information that may exist currently in the tropical cyclone product suite, we were able to kind of tease out from the study by Rebecca Morse that partners find timing information very important for decision making. These products are very important to them right now. They find a lot of value in them when trying to make different types of decisions. The one way that we could think about improving them was that partners expressed interest in additional information about anticipated hazard timing information. And so Rebecca and her team recommend that before expanding the arrival time product suite, some participants offered some feedback that might be taken into consideration. So when it comes to kind of the broadcast sector, the broadcast community, they felt as though these products may have been hard to edit on their devices, or that the data layer may not have been available. Some also said the product provided too much information or is too difficult to understand. So keeping that in mind as we think through what might be the future of timing information in the tropical product suite. And then in terms of emergency managers, they kind of felt similar in some of these areas. They felt the product did not provide enough information that was specific to their local area. So as Gina was just hinting at, a lot of these localization and personalization themes really jump out a lot, or that it takes too much time to understand. And some also said the product could be commonly misunderstood or is difficult to explain to the public. So this is just some initial feedback. We obviously need a lot more if we're going to think through how might these things change, how might they be improved as we continue pushing forward. So Gina, what other things would we need beyond some of the stakeholder feedback?
Next slide, please. Okay, so in these three areas, onset, cessation, and duration, obviously we've got a great graphic currently for arrival time for onset. And so once again, kudos to the Hurricane Center for having products that are already responsive to stakeholder needs. As Castle said, I think that we don't necessarily need to do a full-on social science study, but I think that we could partner with the Hurricane Center and perhaps do some sessions at a national hurricane conference or a space where we could talk more to partners to find out what specific feedback we need to make some of those enhanced changes perhaps to that product. So there are some future opportunities for stakeholder engagement for onset. What's more, though, is we're hearing about cessation. And so the question here is whether the same physical science that's underneath the hood for onset, could we use it for cessation? And what's important here is that onset is supporting more of those evacuation decisions, or like me, travel decisions, right? Some of those earlier decisions. But cessation is really important for when can those first responders get back in to start assessing the situation, or in some cases saving lives, right, from flooding or other hazards, right? So once our first responders and emergency managers have made one decision, now they need forecast information to support the next tier of decisions. And so we're finding that we need something in the area of cessation. The last point is duration. And this is something we hear a lot from our emergency managers with respect to the engineers that have to look at, say, the durability of bridges or the stability of bridges. How long did it sustain tropical storm force winds, for example, because they use that in their calculations for how stable, again, those bridges are. And of course, you have many of those in Florida, in the Miami area, where many of you are located right now. And one of the ideas we had here, and again, this is that question where we're not modelers, but can we do something cool? If you've ever used Waze, Google Maps, any kind of traffic app, when you're stuck in traffic, which we were visiting the Hurricane Center on Monday afternoon in Miami, you've got great traffic there. It told us sort of, how long will we be in traffic? And it has that little countdown and it adjusts as it gets more data. Well, do we have that capability? Could we use our model information and our observations to kind of give some kind of tracker? Or is there some other kind of cool way that we could use the probabilistic information to provide a different kind of, again, dynamic graphic to communicate that type of information? This is sort of one of those questions that are out there for us. Next slide, please.
So kind of going on the other side of the timing information, thinking about how the timing of the release of products, there was a lot of information from broadcasters and emergency managers about how to better align weather service information with partner decision timelines. So according to a finding from Rebecca Morse and her team, more than 25% of the broadcast meteorologists that were surveyed and 20% of emergency managers that were surveyed reported that weather service forecast information could be better timed to align with their decision-making timeline. So if you can imagine, for broadcasters, this really is important in thinking through their on-air newscast times. They need time to update their graphics, their headlines. When things change and when the products and the packages come from the Hurricane Center or other WFO products, they need to have time to think through what has changed since the last update. What might I need to make changes or edits to my graphics and headlines? And they have to do all of this before kind of jumping on air. And so they felt as though there may be a perceived misalignment with how the product release kind of falls in line with some of their newscast times. And the way that emergency managers were thinking about it was completely different, right? They have different decisions. They have different things that they need to do. So with their timing information, they were more interested in receiving information at longer lead times. So for example, storm surge information earlier than 48 hours that would really help them think through evacuation decision-making, other public safety decisions, making sure they have enough buses, making sure they have enough preparations, that the shelters are open. So having longer lead times for some of the timing information would be really beneficial to these types of audiences. And so this leads us again to kind of what Gina was talking about, a lot of questions about like, what can the models do?
Okay, I see Castle knows there's a problem with his sound, so he's gonna figure that out in just a second. So next slide, please. So based on this information, we have more questions than answers. And these are not questions to be critical. They're literally questions for us to have a better understanding. How does the timing of some of the products work? And that's not just targeted towards the Hurricane Center, because we think that this is a more complex question that involves the modeling community and perhaps EMC as well. So it's a genuine question from us to all of you, is how does the timing of these products work, and why is it this way? Again, not because we're being critical, but because we want to understand. In other words, another way to ask the question is, what forecast tool or information, right? Is it a model? Are those times standard with WMO? Like, do you organize that internationally? Or is it just years ago, we randomly picked a time and we've always used it? And again, not critical. It's just a question. What starts the clock for forecast development and subsequent issuance, right? And so the question here is, if it's tied to model releases, how will potential future changes in model times impact this? And can we factor in tropical users' timing needs to align with some of this? We know we have a great social science requirements process with the Weather Service that we've done with Jen Sprague-Hildebrand. And we've talked to EMC, and we know that there, with some of the changes with UFS R2O project and with EPIC and other initiatives, model times may change. And so it begged a question to us is, well then, how will that have downstream impacts on when products and forecast development can happen? And will that impact the timing of those products, right? And so there are some codependencies. And again, beyond our full understanding, which is why we're asking. And so if we could change the timing of product issuance, how might we go about changing that, and what are impediments? And I ask that I use the word impediments because we might not be able to change or address every stakeholder need. And it's really important for us to understand why, so we can just communicate that transparently in response to our partners, right? It's okay to say we can't do something, but it's very important to know the why. And so we ask these questions for the sake of discussion. Next slide, please.
So when it comes to kind of switching to our third story, or our third finding, when we're looking at greater than 5 days, so longer lead times, and this ties in really nicely with Ryan's presentation earlier, as well as Jessica's thoughts as well, which is why we were so excited, which was about partners really asked for more information about tropical cyclone tracks and scenarios, forecast models, and forecast confidence or uncertainty. That was kind of the highest priority area when it comes to the tropical cyclone product suite. Next slide. So the findings that really came from this, again, from Rebecca Morse and team's research project, really showed the value of partners looking to other sources of information to find tropical cyclone tracks and threat scenarios. So you'll see on the screen, there's a lot of spaghetti plots. And that's because in the absence of an official Weather Service forecast product, partners did seek out this information at longer lead times from other sources. And they were looking at numerical model output. They were looking at spaghetti plots. And the fact that Weather Service partners are seeking out this unofficial information at more than 5 days of lead time really points to this important gap in the product suite. And Gina, I'll throw it to you on the next slide to talk more about what that might look like.
Great, thank you. And in fact, I think we've actually already started talking about it this morning, which is to say that we need to start communicating scenarios or start doing something dynamic. And I want to pose this question, actually, it came up this morning to me, is what are our communication requirements? And I asked that because, when I was doing cone of uncertainty work a really long time ago, at this point, practically 15 years ago now, 10 to 15 years ago, we needed a static cone. I was told we needed a static cone because it needed to be printed in newspapers. And so the question is, 10 to 15 years later, are we in a place where we don't need a static cone? Could we go dynamic or interactive, right? Because that CAT idea, the dynamic CATs, communication assist text, could simply apply to the cone. And so one thing we could do right now is make the cone clickable. And if someone clicks on where they are in the coast and they're somewhere in the error area, it could explain what that error means, right? As an interactive way of communicating that uncertainty. That is one way to do this. But there are a variety of other ways that we could communicate this uncertainty or historical error. I also think, and I want to emphasize this, that there's really an opportunity here for NOAA to be a leader in STEM education here. To talk about, model uncertainty. I think we have an opportunity to communicate some kind of product or service that would communicate those scenarios based on our model information. Exactly how? Well, I think like Ryan said earlier, I think we need to do this together and be collaborative together. I think there are a lot of cool ideas here. And again, I want to give kudos to the Hurricane Center. They do have multiple products here. And I think the Tropical Weather Outlook is a way to communicate some of those scenarios. And I think what we're seeing is that we need even more. And there was discussion earlier about, well, but what if the scenarios look different than the official forecast? Well, they should look different than the official forecast, right? They're scenarios, they're playing to that uncertainty. We've seen this in winter weather, doing some social science work there. They have a way of showing the official forecast in the middle, but providing two different opportunities to the left and right of it. For that, it's expect at least this much snow with the potential for this much snow. Okay, so we might not get into the intensity of that, but we may want to go, it might be sort of north-south, east-west. It might be a geographical depiction of scenarios. There's a percent chance it could go a little bit further east or a little bit further west, right? I don't know the exact answer, but again, I think there's space here for considering what are those communication requirements and making sure that we understand them as we begin to design new ones. There are many folks in the call that physical scientists and social scientists who have designed new ones, but what are those minimum requirements? Can we go dynamic, for example? Next slide, please.
And the last really important theme area is thinking more broadly, thinking about the entire system, the entire product suite. So when we talk about the tropical products and services, we need to start thinking about them and evaluating them as a suite of products. How do they work together? How do they connect together? And also use social observations, which we'll talk a little bit more about, to continue improving the delivery of critical but equitable hurricane information to support end user decision making. Next slide.
To that end, I think one of the challenges, and this was actually said a lot in the Monday morning session, is that when HFIP isn't base funded and we do supplemental work, we end up doing a lot of product specific work. And the challenge with that is that if we only focus on the cone, for example, I'm just going to throw that out there. If we only focus on the cone, we will, promise you, we will miss the mark on something else. The cone is a contributor, but not the only thing that impacts people's decision making. And so even with recent events, I feel very confident in saying the cone was not the only contributor and perhaps not even the primary contributor to people's decisions, evacuation decisions. We need to look and make sure we understand how is the cone and any other product working together as a suite of information. Yes, the cone is a very highly sought out graphic on web searches, but we also know that broadcast meteorologists are still one of the #1 sources for receiving information during a tropical system. So we know they're hearing a suite of information. Without understanding how people are responding, comprehending, and making decisions to the suite of information, it's very difficult for social scientists to help isolate where are our main pain points, if you will. And so the main point of this is we really need to holistically evaluate the tropical cyclone product suite, which I should say is something that we've really tried to do with these projects the last 4 years. And it's helping us come up with a lot of ideas to address a variety of areas instead of one specific product by itself. Next slide, please. To that end, what do we mean by holistically looking at it? Well, this is just a quick synopsis of how we look at the hurricane product suite from a social science standpoint. There are all these amazing graphics and services, and this isn't even all of them. It's not even comprehensive of all of them, right? But the idea is we can certainly pick one and start doing graphical design, and we should. That's not to say we shouldn't, we should. But again, we can do that, but just by fixing one doesn't necessarily impact the whole. And that's sort of the main point, is there has to be a balance between product-specific work and holistic systems approaches as well. Next slide, please. We're almost done.
And that's what really it kind of one of the interesting findings and takeaways is that perhaps modernizing the tropical product suite really doesn't involve necessarily creating new products or services, but creating services that help pull in the information or tie in the information that is already available from NOAA. And so you can see on the left-hand side, a short-term way that we could think about this is to just provide a website that helps people walk through what products do you use before a tropical cyclone? What do you use during? What do you use after? And there's a really good fire weather NOAA website that already does this. So that could be a short-term solution. But when we think long-term, we need to think what might the physical and social science R&D needs be to kind of pull together all products and services into a single web page, to have it potentially be zip code enabled. So we're getting at that personalization aspect. And it really pulls together or ties all NOAA information together such that when someone goes to a single page, they're able to understand the entire system of products or the entire suite of products versus just kind of visiting one at a time at different times. So next slide. So the last aspect is thinking more about social observations versus just physical observations. So as the title says, we need physical observations to improve the forecast, but we need social observations to improve forecast communication. And so one of the 4 projects was really about collecting those social observations during the predictive phase to really help understand and collect this novel perishable social science data, to really understand how people's perceptions, how their behaviors change as tropical cyclones evolve. And so these results will be critical for NOAA and its partners to understand how the evolving tropical cyclone information ecosystem and all those products, the product suite as a whole, really shape people's perceptions. But it also can provide improvements on how the system is working as a whole and where we might need to make changes so that it's more fluid, more connecting, etc. So Gina, next slide. What might that look like in the future?
Yeah, so this is the next 10 years of HFIP. Based on this information, is there an opportunity in the future to do some social observations to impact real-time operations and messaging? And so I came up with the acronym CRTSI, a Center for Real-Time Societal Insights. Could we, the same way you have drop zones and you have observations coming in during a hurricane, we could too. And this particular project, also run by NCAR, led by Julie DeMuth, created a proof of concept methodology, her and the team, to give us the capability to do this. Andrea Schumacher was also involved. There was a lot of interdisciplinary aspects to this. What could a future look like if we actually incorporated social science in a real-time capacity? So I leave that for you for fodder for future impacts. Next slide, please.
And I'll just wrap up by saying, again, this process is iterative. We're constantly working with the tropical roadmap and looking forward to the next month of interacting in a lot of different formats and settings, hearing feedback, especially at this conference as well. We look forward to your feedback during the discussion later today. Next slide. And this is just an overview of the team, and we look forward to questions during the later discussion. Thank you, everyone.
Thank you, Castle and Gina. Okay, you got the fire hose. Great job summarizing all of those projects. I did see a few physical scientists checking email, but I'm going to call them out not now, but they did pay attention. So any questions in the room? Comments, suggestions? Shock and awe. All right, John, go ahead, and then I'm going to get Andy in the room. State your name, John, before you go. Can't hear you, John. Okay, Andy Hazelton.
Interesting presentation. I thought the slide about that people are interested in the timing aspects like onset duration. That was particularly interesting. So is that something we should be looking at evaluating for models? You know, obviously some of that goes into the track error, but like specifically whether landfall was, you know, the timing was 6 hours too early, too late, and maybe how that impacts perception. Is that something we should try to quantify more?
I would say yes. I mean, we certainly can't tell you how. I'm not a modeler, but I think this is where social science and the modeling community kind of converges. And of course, I see Jessica's comments. We definitely need to involve the tropical program and the Hurricane Center in these conversations. But yes, I'd say all sorts of questions about timing emerged across many of the projects. And so I would say that the more information we could get out of the models, or again, thinking about that visualization of that, again, taking some inspiration from Google and Waze and other traffic models. Are there other unique ways of showing that information? I'd encourage you to say yes. You guys are already doing really cool visualization, and I think there's some space here for co-development in the future as well.
Andrea, online, please, your question.
I hope I'm not saying this as Mark is standing waiting for to speak, but I just wanted to pipe in that Mark DeMaria was one of the core people who developed those time of arrival graphics off of the ensembles that go into the wind speed probabilities. And I know that he, through those capabilities, has created also time of departure of different wind thresholds. So, you know, in terms of can we do it using the current methodology that's being used at NHC, the answer I think is a definite yes. And so I think I would just encourage you to maybe start there. I think there's a lot of potential with model ensembles as well, but if we're just talking about could we turn a switch on tomorrow, I think that's actually a yes.
Okay, Bill.
Yeah,
Oh, go ahead, Gina. Sorry.
I was just going to say that's great. And again, working with Jessica, you know, these are the things that we're trying to look for time. How could we be responsive now versus in addition to how could we be responsive in the future? So that's great information.
Okay, Bill Ramstrom.
Hi, so thinking from the modeling perspective, again, timing, but I'll say maybe it's a little more about cadence. So, you know, we run our models every 6 hours right now. There's a lot of reasons why we're waiting for input data. You know, it's an elapsed time for the computation to go on. It's an elapsed time to generate the post-processing things. It's probably not easy to change those. However, what I wonder is, you know, we run every 6 hours. Is that the right cadence? Should we run every 3 hours or, you know, some other option? That's probably easier to fiddle with than, you know, pinching those times in, because there's a lot of things that are just, you know, take time.
Yeah, you all work within a system too, right? So we have to understand and respect that. And again, and I think James Franklin might have said, I think it was in the, I think I got the name right. Sorry if I didn't, that broadcasters have been saying they want earlier information for years, even decades. And that's true. But at this point, we're also hearing it from emergency managers as well. So a lot of, and you already know this, a lot of their decision timelines they have to make these decisions before we have official warnings out. And so the warnings often act as confirmation to support their decisions. Doesn't mean they're not valuable, extraordinarily valuable, very valuable. But it's that whole product suite that's really helping to support those decisions in advance.
Yeah, so Gina, one thought that comes to mind, sorry, is the whole facets idea and the, you know, forecasting a continuum. What are the actionable timeframes? For example, the cadence could be what it is now when the storm's out at sea, but as it approaches shore, you may want to change your cadence. You know, I know the Hurricane Center already does intermediates every 3 hours, and then they can do hourly. So is the product suite flexible enough to do that? We have one more question here, and then we'll go to Mark.
Frank, you set me up nicely. I think from feedback I've received just from my personal experience from the lay population, and it kind of blends into what Frank said about the continuum. I think, you know, going back to the cone, even though it's not everything, one of the problems that I get from it is that it gives you a binary impression. You either are or you aren't. You know, you're either in the white area or you're not, right? But that's not really what's going on, you know. And it might be that, you know, a better visualization of just graduating the white from white in the center towards less white towards the edges and bleed it out beyond the 67% line, right? To further, to give people a true impression of what's really going on. And this is a kind of off the shelf idea, but I think it has some support from some of what you presented.
Yeah, and the visual design and geography map cartography design would support that as well in terms of communicating uncertainty. It can get a little tricky because people do want boundaries, and it can also be challenging for some of our technology because the technology wants to know if you're in or out too. So again, we have to sort of think about that end goal, and then we can think about technology changes in there as well. But yeah, great point. And to answer John Cortinez's question in the chat really quickly, about are there examples of something like curtsy being used in other fields? The answer is yes. The Center for Disease Control has a group that does real-time media monitoring. And what they do, you can imagine they use it extensively the last few years, is they do media monitoring to see how their messages are propagating and how it looks like shared by other media. And if they see messages that are incorrect with the science, they will issue press releases and try to encourage correction of that information in real time. It's a little bit different than what we're saying, but it would be sort of the same, a similar idea. And so I think we could look for others to sort of support the development of that.
Okay, so we're going to move on to the last speaker. We're going to have a break, and then we're going to have a panel discussion. So we'll have more opportunity to interact with Gina Castle, Jessica, and Mark on some of the things that we discussed and expand on them. Mark DeMaria is next. Thank you, Mark, for waiting.
Yeah, no problem. That was an interesting discussion, and some of that will enable me to gloss over a couple of my slides because I had some of the same points. So I'm going to talk about the some of the tropical cyclone product development while we're doing at CIRA. There's a lot of contributors here. We're working with the Atmospheric Science Department and other groups. And also, I just wanted a reminder that the CIRA project also supports the on-site person, a diagnostician at NHC, and that currently is John Martinez. And that's been we've had that position there since pretty much the beginning of HFIP, and a lot of the NHC employees actually went through that. Wallace Hogsett, I think, was the very first one, and is now the NHC SU. And Dave Zielinski also went through that, and he's one of the lead developers. So that's been a really valuable asset. Next slide. So I'm going to talk a little bit about the projects that are really directly supported by HFIP or by NOAA-related funding from JTTI or the Joint Hurricane Testbed. The first couple are looking at guidance products, the first four there. And then the last part, I'm going to talk a little bit more about products that are related more towards documenting wind hazards. Next slide. But I did want to show this schematic diagram, very crudely, how we go from observations and models to hazard products. And on the left is I sort of highlighted in red that Stephanie and also Brad talked a little bit about this the last 2 days, is that that information goes into the forecast centers, the Hurricane Center, and also the weather forecast offices. And from that, they produce a deterministic forecast. And then from that, they derive a bunch of hazard products. And I think really the first 3 quarters of HFIP is focused on how to go from that middle left box to the deterministic NHC forecast. And the part that really hadn't made its way into the product suite is how that information makes its way all the way to the hazard products on the right. And so I have a couple of ideas on how maybe we could help with that last step. The other thing I wanted to point out is that I know people are probably very familiar with the Hurricane Center products, but maybe less familiar with the Weather Forecast Office products. In the bottom right there, I mentioned these surface wind and gust grids. The weather offices have to put those out to 7 days at 1 hourly intervals out to about 2 or 3 days, and then 3 hours after that. And so they have to provide a full 2-dimensional surface wind field and a gust field to go with it. And the Ocean Prediction Center and also NHC's Tab B unit has to do the same thing over large marine environments. So again, those are important weather service products that the HFIP models can contribute to. Next slide. And this is just an example of at least the Hurricane Center's version of the various hazard products that are put out there. Next slide. So the first product is, this was some work on machine learning, and this is really to improve guidance for the forecasters. And the idea here is that I think Stephanie may have mentioned this, that there's been a gradual decline in the availability of microwave imagers over the past decade. And yet that's an important measurement for estimating tropical cyclone structure. So the idea is that the new GOES imager, starting with GOES 16, has 16 channels and 2 kilometer resolution in the infrared. So the idea is that, can you use machine learning to train a method to extract similar information to what you see in the microwave, but from the GOES channels? And this project started out with a little bit of HFIP seed money, and now it's been taken over by the CSU has is a joint member of a National Science Foundation funded AI Institute, and they're continuing this work. But the idea is you take microwave imagery from AMSTER-2, from GPM, and then you train the GOES data on it to try to reproduce the satellite imagery or the microwave imagery, but from GOES. And go to the next slide. And this has really been pretty successful. This is an example from Hurricane Ida. The diagram in the bottom right there is one that uses a convolutional neural network. And basically what that does is it tries to extract spatial patterns out of the imagery rather than just on a point by point basis. And you can see there that in the upper left is the observed from low Earth orbiting satellite microwave image. And the bottom right there is what's coming directly from GOES. So I feel like this has a great potential to fill the gap. I think that's something that maybe we want to try to demonstrate possibly in the test bed in the next year or two. Next slide. Also, Sarah also supports the HFIP corrected consensus approach, and this is Ben Trabing's work. And the work that's been done in the past year was updating the model for 2022. But also the HICA was written in this NCL code, which is, I'm not sure NCO even supports it, or maybe they won't in the near future. But Ben did a great job of converting that to Python and converted and moved it over to the new WCOS. And the big task for the coming year is how to tune this so that it can use HAFS. And I'll probably say it 2 or 3 more times, but the sooner we get the retrospective runs, the better. So we have time to do the training. Next slide. Another consensus model we've experimented with is just to try to get our feet wet in the machine learning world for a consensus model is a neural network intensity consensus. That the prototype uses 4 input models, some storm environmental information, and then uses a machine learning technique to try to come up with a consensus forecast. And this has actually been run operationally on WCOS since 2020 in kind of a background mode. But the metric for success is if the corrected consensus is better than just the average of the 4 models that went into it. And now that we have 3 years worth of data, in the Atlantic, it works pretty well out to about 24 to maybe 36 hours. And in the East Pacific, more like out to 72 hours. So it shows the potential, but it also, in hindsight, we know that this is badly overfit. And so the emphasis in the past year was to try to use some of the Python tools to prevent overfitting. And we couldn't make changes in 2022 because of the WCOS moratorium, but I hope to get an improved version of this on WCOS in 2023. Next slide. We also support NHC's statistical model suite, the SHIPS model, LGEM, and the Rapid Intensification Index. Again, no changes were allowed in 2022, so we used the time to update the various satellite databases and ocean databases, and also to work with John Kaplan at HRD on the Rapid Intensification Index. But the bottom half of this slide is just a point I wanted to make, is that this is a problem that machine learning people love to do. It's like almost everybody I know in machine learning has their own Rapid Intensification Index. It's a good test problem, and I've listed there's probably 7 or 8 that I just jotted down off the top of my head, and almost everyone says they're better than the operational model. So I think there is some validity there, but the challenge is going to be from an R2O perspective is how do you extract all this new information and put it in something that NHC can actually support? I don't see Wallace standing up and said, yeah, we would really love to support 10 more models written in 10 different languages. So I think there's some infrastructure needs to be developed at NHC to be able to take advantage of this, this new research. Next slide. Another guidance tool, this is Alan Brammer's work under a JTTI project. There's a tool called the Tropical Cyclone Genesis Index, which provides a probability of genesis forecasting. And this was actually developed under the testbed about 10 years ago, but it never really took off at NHC because it didn't really provide the type of information they need for their tropical weather outlook. And so Alan's new project is to run that in an ensemble mode. And then he can make diagrams like that on the right, where he shows areas of 48-hour probabilities and 120-hour probabilities that is more directly related to what an NHC forecasts. So I think Alan plans to run this in parallel in 2023 so that possibly he can get some feedback for potential operational transition in the future. Next slide. Okay, so the rest of the talk is going to be talking about wind hazard products. CIRA also supports the annual upgrades of the operational Monte Carlo model. The diagram on the right is the cumulative 34-knot wind probabilities and the companion time arrival product. Again, no changes were allowed in 2022, but in 2023, we plan to update this with the latest error distributions. We've gotten some feedback from the weather forecast offices the past couple of years about some unsteady behavior for systems that move over land and back over water. And we've got a solution for that we hope to implement, and then just do some minor code cleanup so we better meet NCO standards. So nothing major planned with the current wind speed probability model. Next slide. One of the applications of the wind speed probability model is the wind hazard recommender. And that's a tool to give the weather forecast offices objective guidance for putting up their inland tropical storm and hurricane wind watches and warnings. Because the offices have different areas of responsibility. In the past, sometimes there was like disconnects. One office would do one thing, another office would do another thing, and you see these weird boundaries. And so based on some work that Andrea Schumacher and I did probably 10 or 15 years ago, we showed that you can pretty well reproduce the Hurricane Center coastal warnings just by applying thresholds on the wind speed probabilities. The trick to it is that you need a different probability for raising a warning than you do for lowering one. That once a warning is up, you need continuity, and forecasters don't like to lower it until the threat is really gone. So it's based on that fairly simple idea, but this is something that is now in the AWIPS 2 baseline. And the WFOs have been looking at this for the past 2 or 3 years, and I think it's really been pretty successful. The relevance for HFIP is that anything you can do to improve the wind speed probabilities will go directly to the Weather Service offices for them to improve their watches and warnings in inland areas. So we've got the second half of the pipe done. Now we just need HFIP to figure out how to get the probabilistic information into the wind speed probabilities. Next slide. Another weather forecast office need, I mentioned the 7-day wind grids. The National Hurricane Center forecast basically is track intensity and a couple of wind radii. So it's not a 2D wind field. So this project was originally started by Craig Maddox and Pablo Sanchez from Craig used to be in my branch and Pablo was the MIC in Miami. And the idea there is we take the NHC official forecast, fit a parametric wind model, and then over land, we apply a little bit of physics. We've got a land surface model that we use so that you can see the different land surface features. This is already being used by the weather offices to calculate their grids. But the thing is that this is consistent with the NHC forecast. That's the real value of it compared to using a numerical model. And we'll run this again in real time in 2023 and looking towards maybe 2024, 2025 to transition this to operations. Next slide. The next big step is to try to impose consistency between the WTCM, the land surface model, and the wind speed probabilities. So Andrea Schumacher is leading a JTTI project to create all of the wind speed probability products, but instead of the way we do it now with a very simple wind model, is to just run the WTCM 1,000 times and calculate all the products from that. And you can see there on the left is the operational product. This is again for Hurricane Ian. The middle product is the same 34 knot winds from the WTCM, which has actually been calibrated against observations in inland areas. And it looks kind of the same over the ocean, but over the land, it's really different. The current model way overestimates the probabilities in inland areas. And so we feel like that this is going to be an improvement in terms of accuracy, but there's all kinds of messaging challenges that go with this. And I have another slide that's going to talk about that. One other nice thing is that because now we actually have wind fields, we can calculate exceedance products directly from those. And on the right there is an example of a 10% exceedance product. Next slide. I mentioned we did run this in the background in real time this year. And every time we run something new and look at it day to day, we find new things that are usually wrong with it. And there's a pretty bad aliasing problem by using a 1 kilometer land surface space and subsampling that at 20 kilometers. And we've got some technological solutions to that on how to pre-process the land surface database so that doesn't happen. Next slide. We're also doing a small social science project to get information from users on the design of possible exceedance products. Again, this is Andrea's leading this. And she's working with a grad student and her professor from the communications department to come up with different scenarios on how to display exceedance products and get feedback from users. But the really more challenging aspect of this is if we dramatically change the wind speed probabilities, and I think Gina touched on this as well, that there's all kinds of downstream effects for the hurricane threats and impacts, how the users interpret the products. So there needs to be a huge amount of work to assess how a change to a product that big is going to impact all the downstream users. And that's a study that I don't think we actually have anybody do it yet, but there's a big need there. Next slide. I also mentioned the Weather Service has to produce wind grids and also gust grids. So we've got this says JHT, but it's not. It's really the HFIP modeling program funded this work, is with HRD with Andy Hazelton and June Zhang and a group from operations. We're developing a gust parameterization directly for the HAFS model. We've just started this, but we were able to leverage a very large database that we have of ASOS and weather flow stations that we put together for the WTCM. And now we're going to apply this to help to tune the parameterization scheme for the gust parameterization for the HAFS model. Next slide. And kind of finish up here with some ideas on, so how do we get more dynamic model information into wind and surge products? And there's nearly all of the uncertainty in those two products, a wind speed probability model and P-surge, comes from climatological error distributions. So there's two options I wanted to present. One is the national blend of models, and then one is a machine learning option for doing that. Next slide. The national blend of models is the idea was that the Weather Service wanted their forecaster to spend more time doing decision support and stop spending so much time creating all the little details of these gridded forecasts that they had to do. So the idea was to try to come up with a scheme to blend all the available model fields together and put it in, give them a good first guess for the wind grids. And so that would free up some time. They tried this for hurricanes, and using the HWRF, the HMON, and the WTCM puts the storm in the right place. And if you do that blindly, bad things happen from this picture here. the HWAR position was way to the left of the official forecast, and HMON was hidden underneath. So this was a storm with three eyes. And Jeff Wagner, one of the developers of this, I think he drew those black lines on there. That's not part of the product. But yeah, that was just his opinion of the product. There's been a big effort to make version 4.1. I think that was funded under Hurricane Supplemental, is to do this storm relative. Next slide. And this is an example of the 4.1 that was run operationally. I just grabbed this from the website for Tropical Storm Nicole, and just one center. That's progress. So, but the idea is that in the outer part, the HWARF right now, and it will eventually be HAFS, the information goes directly into this product that goes out to the world. So this is another way that the model forecast can make its way into official Weather Service forecast products. Okay, next slide. And I'll just end with a new JHT project. And the idea here is that we're trying to use machine learning methods to take all the information that we have from multiple models, from ensembles, and then use those to directly predict the NEC error distributions. Next slide. So the idea, this is a method that was developed by Libby Barnes from the CSU Atmospheric Science Department. I'm working closely with her. And the idea is that you take a bunch of input from different models, but instead of just trying to predict the intensity of the track, you predict the entire distribution. In this case, it's a distribution called the SHASH distribution, which is like a Gaussian, but it allows for skewness. And so from that, in real time, you can actually predict the distribution forecast by forecast. Next slide. And it comes up with things like this. On the left is the distribution for a case from Hurricane Maria in the Pacific. The black line just shows the error distribution given the ensemble information we have. And on the right shows the track distributions. Next slide. So the idea is that those blue lines I added, it's providing like new pipes to get information from ensemble systems. My arrow flipped around, but that's supposed to go the other way, is that we can take the deterministic and ensemble models, run it through a machine learning algorithm, and then pump that back into the P-surge and wind speed probability models to get situationally dependent track and error estimates. So final slide, and that would affect the downstream hazard products. So I'll just leave it here that Sarah is doing a lot of work with product development, and I'll leave it at that. Thanks.
Thank you, Mark. You guys have to be reminded to clap. Any questions? Any questions for Mark? They were stunned. That's what it was, Mark. Zujin.
Mark, you use those machine learning technique. So how can you deal with the model year-to-year upgrades, modification, all these, it's not a stable, unstable situation.
So I guess you're asking how would it do, for example, if your model situation was
so you
unstable?
you need to change your model every year, or you just like continuously, you need 3 years or 5 years data to change your.
Oh yeah, we do need, I would say we need about 5 years of data to train it. That's probably about right. But the nice thing about the technique is that we're trying to predict the NHC error distribution using ensemble models. So we're only capturing the part that kind of projects onto the NHC error. So what comes out is completely consistent with the NHC forecast. And that's one of the difficulties with using ensemble systems directly, is that if the ensemble is under dispersive, or it tends to not be consistent with the NHC track or intensity forecast. But this technique takes care of all that, and it produces the errors that go directly with the NHC forecast, completely consistent with them. And if that relationship is weak, you're going to end up with the 5-year climatological distribution. But from what we've seen so far, there's a pretty good dependence on when there's a big ensemble spread. The NHC error distribution is wider. It does work that way.
Okay, so we're going to take a break because we're going to have a discussion, and all the speakers, I want to thank you for great presentations, but stick around. We're going to take a break. Everybody has a little biological issues we have to deal with. And then we're going to come right back at 10 after or 5 after.
10 after is good. We
All right.
have a little wiggle room.
All right,
I just real quick, while people are starting to head to their coffee break and bio breaks, I wanted to give some on the fly updates on the schedule that we're doing. So as Frank said, we'll come back at 11:10 and we'll start the brainstorming town hall for the social, economic, and vulnerability risk forecast for this previous session. And that'll run until approximately 11:40. And then we'll have John Warner do his presentation on coastal impacts for TCs. And as soon as that ends, we'll break for lunch. So lunch might start 5 minutes later, but we have an hour and a half, so we have some wiggle room in there.
Okay, so while you're taking your coffee break or whatever, the goal of this discussion is to come up with some ideas or concepts that we could test through the tropical roadmap, through using the HOT Center in the next year. And the reason the timing is critical, the tropical roadmap team that Jessica leads meets next week. So I promised her we'd kind of boil down some ideas and give her some suggestions. And then 2 weeks later, there's the NOAA Hurricane Conference when all the WFOs and region folks get together that we can then run those ideas by. So put on your thinking caps while you're drinking a cup of coffee, take all the information you heard, and let's think of what we could do, what we could suggest on projects we could work together on to help improve our communications. So thanks.
All righty.
Okay, so as I mentioned before the break, our goal here is to try and think about Jessica's thinking about the end product, and then all the information that we heard about the scientific projects that Mark raised, and that the issues that Castle and Gina brought up from our social behavioral science discussion. And what I want to have a discussion on is what we think we could do in the near term to start implementing some of these ideas. If there are any low-hanging fruit, or there's some, to use a bad euphemism, low-hanging fruit, but to kind of come up with ideas that we could present to the Tropical Roadmap team next week to think about, and then possibly to WFOs. And the way I look at this is HFIP is transitioning from the National Center perspective towards the WFO perspective, because they're the actual product deliverers. So, the things we've been thinking about in HFIP for a long time have been focused on NHC's needs, which are easier to deal with because it's one entity, a very key entity. But now the WFOs, NHC has to think about how they interact with them. So first up, Avichal has a comment.
Yes, so talking of low-hanging fruit here, we're about to start a project on generating some HAFS ensembles retrospectives. Though the prime motivation is to do that for generating storm surge relevant information. We'll be running, we'll pick some storms of which had landfalling impacts, and we'll be running hopefully a fairly big ensemble size for each one of them. And that information can be fed into generating perhaps demo products, which some of it I think was discussed earlier today. And that would be a good starting point, I think. And we'll be generating the ensembles anyway, and the information will be out there for people to look at and see how in the future, if we do have an operational based system perhaps how these results could be used.
Yeah, so Mark gave us some ideas right away, as did Ryan, of things we can do. And so a question that comes to mind, do we need HAFS ensemble? Obviously, do we need high resolution ensembles, or can we use the GEFS, which exists already, to kind of start doing things? Ryan kind of gave us an idea about, using bias correction or quantile mapping, strategies. I wanted to know how that might interact with Gina and Castle's triangulation ideas. Do you guys have an idea of what might be the first thing we should be focusing on if we had the ensemble information? Is it timing? Is it?
I see. Gosh, Castle, I mean, there are lots of needs. I'm looking at Jessica too here. I mean, I don't think we've put him in a priority order, and I would almost be a little bit concerned about me saying that without conferring with Jessica and Robbie as well. I mean, timing definitely was a big one, but so was intensity. We just didn't have like enough data on that, but I would argue that's up there. Jessica, Castle, I kind of want to ping both of you too. I don't want to be alone on this one.
I hear you, Gina. I think that we've heard a lot about the needs of partners for information beyond the watch period. So something, focusing in on the HAFS ensemble and trying to find that point where we could be leveraging something like the HAFS ensemble to populate messaging because we have enough confidence in the forecast. Like we're like a project that kind of looks at where our predictability can change dynamically with each storm, and potentially even change like what information goes into the public facing products based on that skill level. How can we ever get to the point where we can incorporate the dynamic information, especially at those longer time ranges, in a responsible way? And how would that look like? Does it have to just be a switch where it's either all statistical or all dynamical, or is there a point where we start switching from a statistical solution to a dynamical solution? And I think that the place where the partners seem to be most interested in, though, is that 5 to 7 day time range is when a lot of key decisions need to be made. So if I were queen of NOAA, that's where I think the most bang for the buck may be.
Well, and I'll add to what Jessica said. Yeah, I would say like day 4 to 7, right? Like you said, the evacuation window. Obviously, that doesn't help us with things that are more short fused that form right off the coast. But I think when we talk about timing, I think we have to remember timing of what? The timing has to be connected, right? It's dependent upon some risk. Timing of the wind, timing of the surge, timing of the rain, timing of what? And so timing is never by itself alone. So just to add to what Jessica said.
And I think I'll just chime in a bit and say, it's hard, but I think the other big theme that arises is making those earlier 4 to 7 day forecasts and information more local and more personalized too. And that is going to be challenging, but perhaps that is a place that we could start to move toward. Like, what would that take? How are the models involved in that process as well? And then one other thought that comes to mind too is that a lot of the partners, both broadcasters and emergency managers, understand that there is a lack of certainty involved in providing information at that 4 to 7 time frame, but they want it anyway. They want you to tell them that it is uncertain, and they're okay with that, that they know that there's uncertainty involved at those longer stages, but they want to make decisions using that uncertainty information too. So I think that's also important to highlight and point out.
All right, Aaron has a comment, and then Mark DiMaria.
Castle, thank you for wording what you just did about them wanting the uncertainty. That actually fits really well with my comment. Gina, I know you and I have had some sidebar conversations like at the Epic Summer Workshop and just here and there. So have you guys worked on developing any type of product, at least notionally in your head or in a drawing or something similar to what's been done with time of arrival of like nor'easters and snowstorms, where you have expected arrival of specific amounts or intensities and timeframes? Again, that's more of a short fuse near-term thing. It doesn't necessarily work for moving a lot of population out of an area like New Orleans or Southern Florida. But I think when you were saying on what types of products this could be used for, using that kind of messaging for wind arrival, rain arrival, coastal inundation arrival, flood arrival is and percentages on those are something that I think the public would take a lot more seriously than not understanding the etherealness of the cone is the uncertainty of the center, not the uncertainty of the impact or influence of the storm.
Yeah, great question. So we've definitely thought about it, not that we have anything mocked up. We're not developers ourselves, but I look at a lot of inspiration. Again, we've done a lot of product specific work, but I think there's a lot of ideas that are transferable, especially as it relates to communicating uncertainty. And rather than reinventing the wheel, we should look at other hazards to learn from what we've done. And I think the idea of looking at what the Weather Service has done really nicely and their probabilistic graphics, again, they have the official forecast, which is considered the most likely. That might be different for tropical. We may not want to have the official based on most likely. We might want the official based on a higher risk, right? Because we want to make sure we're saving lives in a different, not everything's transferable, but the idea of having the official forecast in the middle and having two scenarios on either side. So for winter, it was expect at least this much snow. So essentially, this is the minimum amount of snow you should expect to experience. This is the potential for this much snow. And of course, that gets the skiers really excited. Well, you could use something very similar in this regard, where you could say, expect bare minimum this intensity, but there's the potential for this much, right? So I think there are ways that we could look at other product suites to think about how could we communicate that span, right? And so maybe the expect at least this much is based on the official forecast, right? But maybe the potential for this much is based on possible intensification and giving someone a heads up that it's possible, right? I think where we get into tricky situations within tropical, which is a bit different than winter, right? The loss of life is different here between winter and tropical. Let's be very clear about that, right? We're talking about riskier situations. So I think we'd want to give a lot of thought and consideration for how, not every system, the intensification is going in the strengthening category. It could be in the decreasing category. And I think we need to think about all those types of messages and how a product could work under all those scenarios to make sure we're being very careful about communicating those risks in a way that still has the end goal of saving lives, protecting property as the primary goal.
Okay, great. Thank you. Glad to hear that, because I think you're right. Leveraging existing products, or at least making adaptations to tropical specific, is probably something we should consider rather important, because the public already knows what these other products they use in other areas of the country are for other types of weather. All right, thanks. I'll yield to Mark DeMaria with the next question.
Okay. Yeah, if this is a kind of in response to Avichal's question, I think one of the biggest challenges is for the hazard products is going to be, how do you deal with all of the detailed structure over land? We're seeing that a little bit with the WTCM, where we're going from what's been a very smooth product, probability product that was developed 15 years ago, to looking at land surface types. But I think what you can do with the dynamical model ensemble is going to give us way more detail, even compared to that. And so just getting an advanced look of what we're going to be dealing with from a truly dynamical model ensemble would be to reproduce the probability products, exceedance products, and see what the dynamical models show you, and to get us thinking about what we're going to extract from that for hazard products for messaging. And another possibility is NHC's been working on this experimental intensity at landfall distribution. I think Ben Drabing was the lead on that. And that's another thing that would be interesting, just to look at the parallel version of that coming from a dynamical model. So I would say that there were two suggestions of things you could do initially with a dynamical model ensemble.
So given those suggestions, what would we have to do to communicate? Say we did that, what would be needed to make that product functioning and useful? What would be the feedback we might get, and how would we get it to the development? Right now we have ways to test physical science stuff. How do we test the social behavioral aspects of it? How do we get that feedback that they did, like say for the storm surge products? It makes me think of the curtsy and how we could use something like curtsy to test it, but that's a little too open-ended and it doesn't directly feedback. I mean, we're not going to real time, but just getting feedback seasonal. I know, Jessica, that the Weather Service has a process to do that in terms of gating feedback. Can you talk to us a little bit about how that might work from your perspective?
Sure, and I'm already going to give Gina a heads up, but I'm going to be tossing this to her as well, because the Weather Services process is really dependent more on the product or service being pretty mature. We are able to send out products like we have a public information statement and ask for user feedback in a very general way. And we're able to use very general surveys that actually are not applicable to the product itself. It's just a very generic survey that's been approved by OMB. But there's a whole process that we have to go through to get a product specific survey out there, or to be able to do a focus group. So this is where I struggle a lot, because if we want to be able to really make sure that the products we're putting out there have been tested, then either it seems you have to have a social science project, which means money, to do the surveying and the focus groups and gather that information. Or we need to find ways to get people to take a generic survey to provide us with specific information, which is pretty tough. So I'm going to pass this to Gina to see if she has ideas on how to improve or what can be done with this question.
Yeah, so I mean, money helps, right? I mean, I admit that, but I don't know that it has to be a separate social science project. It's almost, if you're in early development, especially if you're on the physical science R&D side and you're really playing with the data to develop something, it's not in a form that you think is going to be transferable for public communication, but it's in raw, ideation form for the physical science community. I don't know that we need a separate project for social science at that time. What you might want to consider is bringing in a social scientist on your project at a small percentage component. What I mean by that is, you might want to get some early feedback on the development of that, because while surveys are great if you have a final product and to try to check, is it doing what we intend it to do? Earlier development work, really, you want more rich detail and feedback. You want more ideation. And that's where I think qualitative feedback comes in. It's more helpful in visual design. So it doesn't have to be the primary focus of the project. It still could be a predominantly physical science R&D project, but bringing in a social science collaborator at a small portion of their time to do some early co-development. And having just visited the Hurricane Ocean testbed on Monday, if there was space for in-person work, the HOT is just a great space to have that interactive exercise done. But I could also say virtual works just as well, and it's lower cost. Because in this case, what you want to do is you want to get, a group of 8 to 10 people together, partners, and you show them some stuff on a screen. And honestly, that's how they're probably looking at it during a storm. So, virtual is okay to get some early co-development. So I would say early stages, early ideas, but as you get slightly more advanced, the need for further stakeholder feedback actually increases, because you're getting closer to, finalizing and finessing that product development. So if we have something that is a more polished prototype, then I think Jessica's right. We may want a separate social science project to make sure that we understand how it's functioning within the system of communication. Because even though I said earlier, I said, we could think about products like expect this minimum amount of wind, but could be as much as this. We also have to be sure, if we have 1 million products, now our partners have to look at 1 million products. And so again, we want to make sure that as we co-develop that one product, we can also think about the whole. And I see Castle's hand up, so I'll pass it to him.
Yeah, no, I just wanted to also add that I think there are some social science like infrastructure projects in place too, like Joe Rittberger's tropical survey, that we could also take advantage of. And not to say that we're going to use any questions on his survey, but oftentimes he has a small section where he can add things or change things from year to year to year to do some experiments. So that could be another avenue for us to explore. Should there be something that has the need for a little bit more quantitative feedback, has gone through some of those qualitative aspects that that Gina mentioned, and you could start to test things in a little bit of a higher stage of evaluation, whereas you don't have to explicitly go out and get more money to do a social science project. But I will say that those questions are limited. There's not a lot of space, so it would need to be in a space where you've prioritized what important feedback do you want to get out of the survey, and also making sure that you know that going into it, so that it can be valuable input at the end.
All right. This is Wallace, Hurricane Center. A couple ideas. I'm trying to think of some practical ideas here. So two separate ideas. One is thinking about getting feedback. Like, we will never be able to get feedback from everyone who's making decisions or uses products. So one idea is we could get together maybe a set of, I'll call them super users. So people who make big decisions that are affecting lots of people. Maybe it's a big emergency managers, maybe it's a media producer, maybe it's a big company, FEMA liaison, a big company that impacts supply chain across the country. Get them together, walk them through an actual sequence of product issuances. And this is not just Hurricane Center. This is bigger than the Hurricane Center, but what are they using to do what they do? What's missing in terms of what they're trying to do but can't do, and just kind of get the feedback from that core group of people who are making these really economy and life affecting decisions. So that's one idea, and that could, the Hurricane and Ocean Testbed could play a role there. The other separate idea is, I don't think we're ever going to know all the decisions people are making, period. We can't know that. So kind of flipping that on its side, how do we build a system, a platform, something that can enable people to make any decision? And what data needs to go into that system? I think we could have a productive discussion if we think about like what a decision-making system looks like. So that's all I got.
Yeah, I'll jump in really quickly. I totally support those ideas. And actually building on what Castle said with the Weather and Society survey, that is a predominantly public survey that Joe Rittberger has been making at the University of Oklahoma. The WPO social science program has been looking for ways to create transferable methods and transferable data that doesn't serve one purpose, but serves many. To that end, in addition to the public tropical survey they are developing, separate from that, they are developing what's called an emergency management weather and society survey. And what we found from that is they actually did a preliminary survey with emergency managers across the country. They built their own sample of emergency managers. And yes, it's agile so that people can update their profiles because there is high turnover in this community. They don't want to take one survey a year. They want to take lots of mini surveys throughout the entire year. We thought that was very interesting. We didn't actually know that. So that is another opportunity for the development space. If you all do have ideas, I think within, Frank, to one of your bigger questions, how we can work better together is we need to know what's available in the development space within the HFIP community so that we can help be sort of a mediator between the ideas being produced by physical R&D and the space that we have on our surveys to test some of these ideas. And Wallace, to your idea specifically about creating a core group of super users, we can parse that survey, which is a national survey of emergency managers, and we can parse it to the tropical emergency management areas so that we can get a group of core users to respond. So just wanted to share that as an idea. In the semi-short term, over the next year or two, I think we would have space to do that.
So, I was just going to respond to Gina on that. We meet bi-weekly HFIP, and once a month we have a seminar. It talks a lot about our detailed stuff, but we would certainly welcome, and as you have done in the past, you've given seminars, I know Castle has, to us, which I think has gotten great response. So I think certainly increasing that interaction will help get us on the same page in communicating what HFIP goals are, what our capabilities are, what our struggles are. I mean, Jessica already knows because we interact with her all the time on this, but through the Hurricane Center. But I think that's something we can do right now. That's actionable. Go ahead, Castle. Sorry, I interrupted.
No, you're good. I just also wanted to add to Wallace's list, both highly numerate and less numerate individuals too. We found that to be a really big finding from the Hurricane Supplemental projects, is any future development, co-development, any revising of products needs to make sure we have users that are both highly numerate and those that are less numerate in the room in the development stage, to make sure any changes, any modifications, any new products have that lens of development too.
Another thought would be that in any proposals that HFIP funds through our different organizations or JTTI, that we look to see whether proposals have a social behavioral component to get funded.
Frank, can I just add something to that real quick? That actually is in our scoring rubric that we have now.
I know, but our reviewers are not paying attention to that because they're physical scientists.
Yes, and that's actually something we are taking into account at the program side when we make the decision. Those scores that come in, we do make tweaks to them based on parts that were ignored from the
Right. So
reviewers.
these are actions I think we can take right now that can help us move forward. I know that we've been interacting more with the tropical program as we've done this in terms of looking at things that we want to run through the hot. And so I think that's another good interaction that we need to keep formulating and building. And I think we're reaching out, but I don't know that we're totally connected. That's the purpose of this activity we're doing right now. Chandra, did you have your hand up briefly?
Yes. Yeah, for the JTTI competition, we do have social science as a separate priority. So, I mean, Gina and I think Andrea Miller was kind of, she was supported her wind probabilities project. So every project may not have a social science component, but of the 3 or 4 priorities JTTI announces, one of them is a social science priority. So yeah, we do. JTTI support a lot of social science projects and still supporting a lot of them.
But what I think I'm saying, Chandra, is combining the projects, not separating them into different announcements.
So that is something the PIs have to come up with. Yeah, I think Gina, I think we have to work on that one. Yeah, right now, physical science projects are treated as physical science projects, and then social science projects are social science. But in a physical science project, we don't have a social science component. As Gina mentioned, maybe that is early on at the research stage, we have to formulate that. JTTI is all about transitioning projects that are already mature, ready to be transitioned. So it is kind of too late to incorporate that in the project when JTTI funds. But I don't know, I mean, sorry, Gina's point is that you have to engage social science people at the early on, like at the research stage. So that maybe if we do that, maybe it is automatically integrated in a project. So
yeah,
I'll
so
say,
I was just
Chandra,
going to say one thing to think about is we have all these funding opportunities, JTTI, we have HOT, we have social behavioral science. Can we, moving forward, have a call for proposals directly that will address an action we can take from HFIP to do a product and do a test and bring together the key people?
Yeah, sure, we can. I mean, I think we have to work together. Gina, myself, maybe somebody from your HFIP team, we can work together and see how it works. Yes, it can be done. Yeah.
well, and just to jump in really quickly, one, even though the priorities are different in JTTI, to support Chandra's point, PIs can choose to do 2 priorities and combine them together in a proposal. And I think we have seen very productive projects that have done that in the severe weather domain, where it is an interdisciplinary team. So I actually strongly feel JTTI is a very good place. And the RLs, correct me if I'm wrong, Chandra, but I believe it's I forget whether you start at 4 or 5, but like in the 5 to 7 space, I still think there's space for co-development in those phases of the development phase as it gets earlier to transition. So I still think JTTI is a good place for that. But I'll also just advertise, we have a current open WPO funding call right now for social science that does include, priorities related to product development with specific requests for how do we personalize or localize products. So certainly anyone could submit a tropical specific proposal to something like that as well.
You guys be open to Jessica's tropical roadmap team giving you requirements that you could put into an announcement?
I should say we actually do include the social science requirements from Weather Service. That is the basis of our science priorities. So we actually do try to incorporate them into our priorities. So yes, we're open to that.
And just, chiming in on that, so the WPO has been provided with the high level requirements from each of the Weather Service programs, and that has been incorporated into the funding calls.
Andrea, I don't want to break this discussion, but Andrea, you had a comment somewhere.
Yeah, sorry, I guess I might be breaking this discussion. I apologize. I think I wanted to follow on from an earlier thread about the idea of integrating social science. And if we have an early prototype, we might just need a little bit of social science time, someone to sort of come in and do some focus groups. And then as we have a more advanced prototype, we want to involve a more exhaustive integration there. I think my question is, so it's really maybe too based on my own experiences with the wind speed probabilities. And you've seen a lot of the sort of what's coming down the pipeline with this new version. And a lot of the things we've run into, which is social science adjacent, I'm going to call it at this point, is that, we need more comprehensive user needs assessments, and we need those to extend beyond the Weather Service. And, I love Wallace's point about we definitely can't ask everyone how they use it and when they use it and et cetera. But even if we were to just focus on the super users, I feel like there are so many super users that we might miss. I know just from publications that there are, the space shuttle has used the wind speed probabilities from time to time to help make decisions on when to keep the space shuttle out versus in. And Buck Sampson has done some work with the Navy. And so I think the Navy or the Air Force, shoot, I can't remember now, DOD, and talking about when to set their different TC cores, the tropical cyclone conditions of readiness. And so there are all these pockets of users that I would consider really important users that I don't think we necessarily have a good handle on. And so I just wonder, this is maybe a larger programmatic question, but for some of these products, it seems like it would be great. I love that Jessica and WPO, you're all working on creating these sort of lists, these internal lists, but when it comes down to changing a product that is already out there and people are using, how do we get a handle on the social science aspects that are needed to make this successful? Because at this point, it's almost worrisome that we can create this new product, we put JDTI funds into developing it, and we're going to hit some major roadblock when we go to try to implement this, I don't know, 3 or 4 years down the road. And NHC might say, well, we can't change it this much. People will, there'll be a lot of ripples, or, they'll just be these, I want to remove the speed bumps. And I'm wondering if there's any way, from an integrated approach starting now, if we could help that happen.
Yeah, I'll jump in and maybe bat it to Casa a little bit. It's a great point. And this is the challenge running a social science program in NOAA, is we have both, again, product specific development needs, and not even at the granular level of change the cone. I mean, tropical, winter, fire weather, right? We're split by hazard, right? But then we also have holistic needs, like you just said, which is having baseline understanding of our stakeholder needs and trying to tell, sort of having user stories or user vignettes of like, here's a type of decision made. Here's the decision threshold that they use, their minimum requirements. Here's how they use a suite of products, right? And not just not just NOAA's products, right? There's a whole information ecosystem out there of public, private, and even academic resources that our partners are using. And frankly, we have to have a fully comprehensive understanding of that, because if we change a part of the NOAA product suite, again, it's almost as if we need to understand how does that blend all together in that information ecosystem as well. So I will say in the WPO social science program, knowledge transfer is one of our biggest growing areas. Actually, Castle is not only our R2O lead, but we're trying to champion knowledge transfer. We have a lot more progress to make, so I'm going to acknowledge that. But Castle, I'm just curious if you want to add any of this to that area of knowledge transfer and some of the efforts that we're trying to take.
Yeah, you went in the exact direction I was going to go, in that I think what Andrea is kind of getting at is the broader information ecosystem of like, where do our products even go? Who touches them and retransmits them? And how does that trickle down effect work? And so I'm really hoping, because as Gina mentioned, we have a current ongoing social science competition, information ecosystems is one of the priorities. So we're actually hoping that the academic community might help us start to understand who are all those touch points, who are all those stakeholders, and how do they differ by hazard? How do they differ by diverse diverse communities and underserved communities, and what does that look like? So I see a lot of bright future for the topic, but I think it's something that we're just now starting to scratch the surface of. We've been thinking a lot about our NOAA products and services, but we have to start thinking more broadly about how does NOAA's products and services transmit outwardly, and how do they change or modify as we start to trickle down throughout the weather enterprise.
Okay, we have time for at least one more comment, but I'd like to point people to the chat. There's been an ongoing chat. Stan Goldenberg and Rebecca have been going back and forth, so please check on that. Zujin Zhang, and then I'll wrap up.
Yeah, one more variable I want throw in here is social science, especially people's behavior, is varied dramatically. So one example I want to say is like on my street, my neighbors, they all look me whether I close my shutters or not, because they know I'm the meteorologist, so they all look that. So when things like yesterday, when Gina tried to find a plane to back to DC, and people's tolerance is different. So what my suggestion is, maybe not only we just get the number from the public, we also need to get the expert, about our products view, because that they do those research and they know much more, the people's psychological behavior when we face the, face some kind of adverse situation. So that's a suggestion I was, would like the social scientists think about that. That's, I don't know. I'm not in that business, so I don't do much. But one example, another example I want to say is that people do the when those like a superstar, they just wear the common clothes, stay in the New York City subway, no one pay attention. But once they put the glass, their custom on that, all people will know, okay, that's Taylor Swift, so they're gonna chase. So that's the different behavior. So I think the public's behavior is easy to influence, but we need an expert give the input on our products.
So
Okay.
I know, Frank, you're trying to wrap up. I got to get a last word in. Two things. One, yes, there are effects of experts on our publics. That goes without saying. But what I want to bridge from what you said is back to Ryan Torn's presentation of, we think about you. both the modeling and forecast community as part of who we study as well. Not to say we're like observing you all the time. That's not my point. But my point is that what Ryan said earlier is that there is so much information for model ensemble, right, that you could do. And so we think about how can we optimize your expert environment. We can help with that too. And so to that end, when you think about analyzing and visualizing all of this information, do we have to do it on a laptop screen? Or could you actually put on a VR headset and walk into the data, if you will, virtually, right? I think there are lots of different ways social behavioral science can interact with this community in the future. The future is bright and it's very exciting.
Thank you, Gina. When we do our summary later today on the wrap up of future, I'm going to try and boil down what I heard. But we do want to move on to John Warner. I think John's online.
Yeah, I wanted to say something real quick before we transition to John's talk. We were supposed to have another coastal impacts talk, but unfortunately, Saeed from Ocean Service is out on a small island in the Pacific for work and was unable to join us remotely from there. Also, I know John had talked about removing this talk so we could keep the last discussion going, but I really would like to have this here. It not only fits the HFIP program that I'm the OSChat modeling PM for, but also the Coastal Act, which I'm the PM for. And I think those two things obviously aren't mutually exclusive. A lot of the work that's already been done with Coastal Act could benefit HFIP and post-storm messaging, not necessarily pre-storm messaging. So John, if you are still on there and available, please go ahead.
Yes, I'm here. I see the slides are up. Thank you for allowing me to present here. I'll say that I was at the meeting for the last 2 days, but I also took the opportunity to fly home early, and so I apologize for not being there on site. But I was there for 2 days. It was great to meet some of the people that I met, and I wish I could have met more people as the time went on. I think this talk is going to kind of divert us from some of that great conversation that we were just having. Here at the USGS, we have very similar conversations too. I'm involved in a Hurricane Ida project in New York and other places looking at social science. And so it's very, very relevant to the work over here at the USGS as well. But today I want to talk about the development applications of this ocean infragravity wave, morphological and structural response coupled nearshore prediction system. A lot of words in there. Most of the funding from this is from an ONR project, this NOP Hurricane Coastal Impacts Project. And I just want to say that we look at like everybody, we look even at regional scales, hundreds of kilometers all the way down to the coastal scale to meter scale. Can you go to the next slide, please? Okay, so a brief outline, I'll try to get through all this, is the NOP project. I want to talk about my coast modeling system, some model coupling, some of the details of the physics that we have to go through in order to get down to these coastal scales, this infragravity wave model that we've developed, and sediment, because we're trying to get coastal erosion and breaching barrier island morphology. We have a test case for Hurricane Michael that we have some examples for, where we've compared observations in water levels and waves, then the nearshore coastal erosion modeling, and then the structural damage assessment is a new aspect that we've added in. Next slide, please. So this NOP project, NOP Hurricane Coastal Impacts Project, NOP is a collaboration of federal agencies to facilitate partnership with academia, industry, and others in the scientific community. There's several tasks on this project. I think it's like a $10 million project or something over 4 years. And we have many different tasks. Task 0 is a group mostly from NRL to provide hindcasts and forecasts of hurricane track and intensity for at least 3 CONUS landfall hurricanes each year. We have task 1 to build and update digital elevation models, because that's something that everybody complains about, is that they don't have accurate and detailed elevations, topographic and bathymetry merged around the country. Task 3 is looking at satellite remote sensing to help build ground truthing for the geophysical measurements that are taken during the storms. Task 3 is for in situ measurements to include offshore waves, water levels, and data for us to assimilate into our models. And task 4 is the actual forecasting of the wave surge, the sediment transport to include erosion and accretion, and the structure interactions. And there's 3 teams for that. And I'm part of one of those teams. So next slide, please. Is a little bit more detail about the project. So task 0 is mostly COAMPs running at NRL. They give us the forecast for the different hurricanes starting from 5 days prior to landfall until landfall. Task 1, there's different groups from the USGS and from NOAA. They're combining these different data sets to give us our elevations, our merged topography elevations, so that we can have seamless grids to go from offshore to onshore. Task 2, there's many different groups, wind fields from SAR images. There's the USGS, and we have our pressure sensors that we put out during the different storms. There's so far private organizations putting out buoys. We have task 3 is dropping sondes from aircraft. And then when we know the track from you guys, we don't just focus on the cone, but we look at the track and we try to put out sensors, pressure sensors on piers and other structures that we've pre-identified along the coast, and to give us some information. So, but we need to know like several days ahead of time so we can get safely out there and deploy that gear. And then task 4, there are 3 different modeling groups. There's one from Deltares, there's one from using ADCIRC. Then we use our coast system, which is a 3-dimensional system, which I think is on the next slide. So you go to the next slide. So this is our modeling system. We've been developing this over 15 years or more. I came up with the acronym COAST. I know there's a W in there. It kind of throws some people. Sometimes it's okay. It stands for Coupled Ocean Atmosphere Waves Sediment Transport Modeling System. We've coupled the atmospheric model WRF with, we started out with WRF and ROMS and SWAN. And over time, we've added in WRF Hydro so that we can get the precipitation. We route it through WRF Hydro, we get it back to the ocean model. And then the ocean model couples, we use SWAN and WaveWatch 3. We're using a lot more now. And we use a coupling toolkit to exchange data fields between all these different components. We've simulated many different hurricanes over the years and looked at interaction of turning different coupling components on, turning the waves on for the stress to the atmosphere, turning them off, for example, things like that. For this particular talk, I'm just going to be talking about the ROMS and WaveWatch 3 and in-wave models, because we're getting a lot of the atmospheric forcing from COAMPs. And the other part that we've added in is the structures part. So we're looking at the predicted impact or predicted forcings from the ocean and using that to predict what the impact will be on the land of the different structures. Okay, next slide. Okay, so let's talk about a little bit about some of these different details, some of the interactions that we've had to develop over the years. So between the wave and the ocean, we exchange different components like wave height, wavelength, different periods and directions, and different energy dissipation terms. And the way that that's used in the ocean model is several ways. Well, we have terms to enhance the bottom stress because the wave orbital motion will enhance the stress on the seafloor, and that's good for mobilization of sediment. We have enhanced surface stress because when those waves break, and with the structure of the wave itself, there's an additional stress, and so that modifies the circulation of the ocean. And then throughout the water column itself, we have Stokes flows and vortex force, which is when the waves break, that energy dissipates and drives flows. And one of the components that's been adding a lot lately in the wave and ocean world is this effect of vegetation. And so how the structure, it's not only vegetation, but how structures and different aspects of the coastal environment, when it becomes inundated, how does that extract momentum from the water column and cause variations in flow? And so it might reduce the surge inland if you have structures versus if it's just an open area. Okay, next slide is going to be the ocean to wave. So going backwards, so from the ocean, we send the currents and water levels and the changing morphology of the seafloor. And the way that the wave model does this is that the ocean currents are used by the generation. So you have to take out the magnitude of the currents from the wind speed in order to get the relative forcing. We also modify the propagation speed of the waves themselves by taking into account the ocean currents. So for example, if the waves and the currents are going in the same direction, it lengthens the wave length, and it decreases the wave height. Whereas if they're in opposition, the wave height would increase. And also there's an effect of the directional space. And this is an example of paper down here of how the Gulf Stream itself, because the Gulf Stream is, meter or two per second. And so that definitely can have an effect on the waves. It can if you don't include, like a lot of the depth average models don't have the Gulf Stream. And so there's not the inclusion of the effect of the currents on the waves. Okay, next slide. Okay, so if you think about waves and the full spectrum, if you think about period, different time scales. So the ocean model typically will get the tides and long waves up to about, from months to days to minutes. And then the wave model, Swan or WaveWatch 3, can get the gravity waves from like 20 seconds down to a couple of seconds, but there's a gap in the middle from about 30 to 300 seconds. That's the infragravity wave band that these models don't capture. So we've developed this model called InWave to capture that infragravity wave band. You go to the next slide. I won't spend a lot of time on this, but it's a wave action balance equation, kind of like what's in WaveWatch 3, but we solve advection equations for the wave energy. And I won't go into the details of that, but it's here for anybody that's interested. Go on to the next slide. And so what we really need, though, to do this is there's again, I don't know if my movies are not playing or not, but on the right there should be an animated GIF that should just play. No, it's not going to play. Okay, well, anyway, so there's an animated GIF that's not playing, but what we need is accurate wave information, and not only just wave height. We use the spectra, so the way that the wave energy is distributed throughout the directional space and in frequency space. And in order to come up with this wave group model, this infragravity wave model, we needed to take the information from the spectra at each different frequency band. We take the amplitude of the energy from that, we use it, the period of that band, and we sum up different envelopes or different time series of water level that energy would create. And then we sum that all up and we get an envelope from that, and that's used to drive these wave groups that propagate landward. And we have to do that over all the different directions. And when we do that, we have these energy packets that transport landward. It gives us the wave run up and the dune overtop. The models like Swan or WaveWatch 3 don't have that dynamic nature in them. Okay, next slide. And then finally, in the nearshore, we've spent a lot of time adding sediment transport capabilities. And I won't go through all the details of this slide either, but there's just a lot of different components that you would think, why does it take so much to just move sand? But it's kind of really complicated, because there's the wave orbital motions and there's different grain sizes, and we can have different sediment layers in the model. And then you have wave breaking and turbulence injection and roller models, and you have to deal with wetting and drying on the land. And we have all these different capabilities that we've been adding over the years in order to be able to mobilize and transport sediment for bed load and suspended load. And then that changing morphology, that seafloor as it evolves, we send that information back to the wave model so that we can predict these breachings through the barrier islands and how that would enhance flooding landward of that system. Okay, next slide. And so then we applied this to many different storms over the years. This is an example for Hurricane Michael, which was in 2018. It sort of, I guess, it started out with a similar track to Ian, but it didn't go to the right. It just kept going straight north, and it impacted the panhandle of Florida on October 10th, 2018 was the landfall. And we had impacts to structures near Mexico Beach. That's an area we're looking at with our structures group. And then for the geomorphic change, there's a breach that occurred in Cape San Blas, which is on the right there. At the time, this was one of the strongest hurricanes to make landfall in Florida. It had 161-mile-an-hour winds, a pressure of 919, and the storm surge got up to 14 feet or so. Okay, next slide. And so we have different models that we ran for this particular storm. We have a larger scale grid for the whole US East, but then we downscaled to a smaller scale grid for the Eastern Gulf of Mexico. We ran both ROMS and SWAN and ROMS and WaveWatch 3 for these simulations. And this grid had about 15 layers, about 900 meter resolution. We have our forcings from coamps for this particular application. And there's some other aspects of the storm there, but let's just go to the next slide. And then we look at the results from the water levels and the waves. They're important at the coast. For the water levels, we have different scenarios where we look at different stresses from the different kind of interactions between the ocean and the atmosphere. And I won't go into the details of those, but there's different ways to parameterize that. And so we're studying which ways are best to give us the most accurate forecast. And on the right, we have different wave model results. And we're running WaveWatch 3 and SWAN and comparing them. And mostly right now we're looking at reflections from the coastline. And so that's why we have different simulations of WaveWatch 3. And again, the significant wave height, which is often what people look at, it might match pretty well, but when you actually look at it in directional frequency space, it doesn't look so well. Let's go to the next slide. And so this is some observations of this is observations from a buoy up on near the shelf, up near the Florida, near where the storm made landfall. And you can see as we get further along in time, the directional information is mostly from the southeast, but as you get further in time, like the bottom middle panel and especially the bottom right panel, you see how there's two peaks. And so what that's telling us is that there's waves coming from the southeast, but there's also energy coming from the northwest. And so we assume that that's reflected energy from the coastline. Let's go to the next slide. And this is another movie that's not going to play. I think it's because it's in Google land, but essentially it shows the difference between WaveWatch 3, a simulation of WaveWatch 3 with reflection and one without. And we get to see the reflected energy that occurs in the Gulf of Mexico, but the movie's not going to play. So go to the next slide. I have okay, so this is basic. So on the left here is the wave height as the storm's coming up through the Gulf. The middle is instant in time on October 10th of the difference of the wave height with reflection minus without. So anywhere you see red is basically reflected energy. And at this buoy, the top panel on the right, you can see that I circled it where the reflected energy is measured. And in the right in the middle there, from WaveWatch 3, we can get reflected energy. But when we use the wave model SWAN, it doesn't have the reflection energy. So WaveWatch 3 allows us to simulate that. And the reason it's going to be important is because it can get up to a half meter or even over a meter higher wave heights at the coast during the storm when we include this reflected energy in the model. Okay, go to the next slide. So then we zoom in and we're going to look at, so those are like the bigger scale pictures. Now we want to look at the geomorphic change near Cape San Blas. So we have a lot smaller grids. We go down to about 4 meters in resolution for about 3 kilometers along the coast, about 2 kilometers in the cross shore direction. And we include these different parameterizations for vegetation to allow when the surge comes up high enough, it's going to feel the vegetated material, or we can also include houses or other structures in the system. Okay, next slide. And this is another movie that's not playing, but basically it shows that what we need from the offshore bigger picture grids is water levels and waves. We use that to drive this smaller scale model that includes the effects of vegetation. And with that, we can get this run up and this dune overtopping and the barrier island breaching throughout the event. But the movie's not playing. So let's go to the next slide. And this is a static image then that shows the top panels before the storm. On the left, we can see the barrier islands intact. And the middle is the elevations that we used. The bottom left is after the storm. there's a aerial image that shows that the breach that occurred. And in the model, then if we don't include the vegetation, we don't include that increased resistance to flow, the model does not predict, or the model over predicts the breaching. We have too much loss of material of the barrier. But when we do include that vegetation effects on the right there, the vegetation reduces the turbulence in the water column, reduces the dissipation of the wave energy, and then we do get a more accurate simulation of the barrier island breaching. So we need to get down to meter scale resolution in order to accurately predict these impacts. Okay, next slide. And I'm almost done here. So this is just some this new part that we're adding in, and I have to read some of the text here, but this is our structures component to all this. And what they're doing is they're using this machine learning framework to predict categorical damage states to buildings in hurricane impact areas. To train the machine learning model, they're using a data set of recorded damage states with building specific characteristics from this STEER structural extreme events reconnaissance data set. And then they selected specific hurricanes, Harvey, Laura, Irma, and Michael. And then each building was paired with observed wind speeds, surge depths for those hurricanes. And they held back some of the data, but they used this to train the machine learning model. So go to the next slide. And it's basically the results from this damage prediction tool. They use what's a random forest algorithm, which is an ensemble of decision trees. They trained the model on the reconnaissance data, and the full data set was used to train the model. It had 18 different features or characteristics, but a key takeaway was that only 9 of the features listed here contribute to the accurate predictions. And those important features were the wind speed, the age of the building, the distance to coastline, the surge depth, the wall structure type, the roof structural type, the number of stories, roof shape, and the wall material. That was information that was needed to best characterize the impact of individual structures from the storms. Okay, next slide. I think that might be it. Okay, so this is conclusions. So we have this KNOT project that's pulling together all these different pieces of the hurricane forecasting, from the observations to the modeling. We applied it to Hurricane Michael with larger scale grids to simulate all the different wave current and water levels and provide boundary conditions for these smaller scale models. The wave modeling showed we really need the 2D directional spectra of information, and the WaveWatch 3 can predict this reflected energy, although it was a little weaker than what's observed, but it's important because it can add a contribution at the coast. We have this new infragravity wave model that can help reproduce these nearshore impacts. We need to look at order of meter scale land use cover features to help have more accurate simulations. And we're developing this machine learning framework to predict categorical damage states to buildings in hurricane impacted areas. Sorry about taking up a little bit longer time. That's all I had.
No need to be sorry. Thank you very much. You've packed a lot of information in there. We have time for a couple of questions. Anybody? I don't see any in the chat. Are there any online questions? All right. Anyone in the room? I think Frank Marks has a question.
Yeah, John, thanks for this summary. I knew a lot of this stuff was going on. I didn't realize you had the NOP to pull it all together. It would be interesting to see how NOAA could take advantage of some of these issues. I mean, this is a research project still, how we would transition some of that technology into addressing the coastal issues. Because right now we really kind of focus more on the land impacts. And we know the barrier islands are a big impact point, evidence Ian and Michael. So have you thought about in the NOP project how you might want to transition any of that stuff, or is that a discussion yet to come? And have you started conversations with NOAA or customers, stakeholders that would be interested in this effort?
Yes, so I have conversed with NOAA. I've been talking to Saeed, who was supposed to be in this session too, and unfortunately he couldn't make it. And I think I'm also trying to learn who else in NOAA I should be talking with. So I'm open to that. And I think the USGS also itself does have a lot of products that we put out, water level products and coastal impact products that we put out. And there are partnerships there with NOAA already, but I think all that could be made better. And yeah, so it's a research project. And I think getting research to operations is also part of the UFS theme. So it would be nice to know how to help transition some of these capabilities that we're developing to know. I'd like to learn more about how to actually do that myself.
Pete Black has a comment online you should check about, and we could fill you in, but Hyun Suk has a question.
John, good talk.
Hi, Hyun Suk, how are you?
Good, how are you?
I'm good.
That's good. That's interesting about the energy coming from reflected waves. So this will come in as a swell, right?
Yeah, I think it would have to be. I think the higher frequency waves would probably get dissipated. So right now the wave arch 3 is kind of under predicting that energy. I need to look more at the frequency distribution of it and try to see if it's the timing of the forcing or what's actually going on. But wave arch 3 at least can give me that signal, SWAN can't. So it's promising there, but I definitely need to look at it a little bit more closely as to what frequencies that energy's in.
Okay, so I ran three-way coupling with the wave watch 3 for Hurricane Laura. And when I look at the wave animations, it's a little bit different from what I see. Michael will be a little bit, going from south to north, but on the other hand, the Laura is coming from Cuba to the northwest. But nonetheless, there is forerunners of the wind generated waves, and then reaches in the Gulf Coast much faster and make a turnaround, along the clockwise directions. But I don't see yours. That is one thing. And the second one is, did you see any wave trapped in the loop currents for this micro case?
I will look. I mean, we're certainly running, a 3D model. We have ROMs that has the loop current in there. And I didn't look specifically about how the loop current is affecting the waves. We saw that, Christy saw that with Matthew, I think it was, she did on the East Coast, on the Gulf Stream there. So I'm sure that the currents are affecting the waves from the loop current in the Gulf. For the forerunner waves, well, my movies didn't play here. I think I should have learned my lesson to know that Google isn't going to play the movies. But because the same thing happened at the UFS meeting. But I'll have to look at that, the forerunners, and to see where that information is coming from, and compare it to Laura. So I mean, these are all good points, and I'll look at that and I can get back to you on that.
Yeah.
Okay. Last one. Pablo, go ahead and talk about your comment, and then we're going to break for lunch.
Yeah, can you hear me?
Yes.
Yes. No, I just a quick comment is I don't know if you guys have interfaced with the group that implemented operationally that we're using now, the Coastal Weather Forecast Office, is the Nearshore Wave Prediction System, NWPS, which is basically the engine behind it, is SWAN. And it's a model that is run very high resolution, hundreds of meters, and it's what we use to do our marine forecast day in and day out. And over the years, we collaborated in the last few years specifically with both the National Ocean Service, the USGS, Joe Long, when he was there working, and we actually incorporated, it was, sort of a parametric approach to the problem, but we do have, from the output of NWPS, we actually have wave runner output that we ingest into our system. It's actually the data that is behind the USGS total water level viewer. So I mentioned that because you mentioned about the right people to talk to on the operational side. No, well, that group will be one that I think we will be very interested to see exactly what you're doing, in terms of how to identify a venue of bringing this capability into operations or to enhance our operational capabilities. So anyhow, I thought I shared that with you. I don't know if you were aware of that particular NOAA group.
Oh yes, I'm aware of that. And the USGS Total Water Level Project, they take your the national weather the forecasts, and they put in a parametric like Stockton run-up equation or something like that to predict total water levels would be, and compare that to the dune heights. And what we're doing is a little bit more dynamic. We're actually running these models that actually are going to predict waves, and so there's comparisons between what we're doing and those parametric regression equations. So there's that's a research area that's very active right now. So yeah, I'm aware of that, and it's a good interaction point.
Yeah,
Thank you,
it's
gentlemen.
good operational.
Pablo, I'm gonna have to cut you off. I'm sorry.
Yeah.
If you guys feel free to carry on your conversation, and at any time that you guys are able to. Maui has one thing to say. I'm not 100% sure what she told me, but go ahead.
So I want to say that I'm standing here kind of on behalf of Saeed, because I have been working with him, as well as the ESMF team, as well as in my capacity as a former Coastal Act program manager and the current EPIC program manager. What we are doing, what we are planning to do starting from next year is actually to establish a new OPSI generic coupled model driver for the Coastal app. And so the ESMF team will start that work with all the coastal modeling teams, including ESERC, FVCOM, ski season, and the ROMS. So I think we should talk. John, we talked about it briefly, but I'll be in touch.
And Maui, I can set something up for all of us if you'd like, since the Coastal Act isn't completely dead. We're just trying to fight for money at the moment. All right. On that note, thank you for all of your time in the morning, especially the panel earlier with the social science discussion. That was great. And we will break for lunch now and be back at 1:30 for talking about the hot test bed, which is the new name for JHT.